Some places remember what they were never meant to forget. Beacon Rock rises 848 feet above the Columbia River, a volcanic remnant that has stood sentinel over the gorge for 40,000 years. The Chinook people called it Che Optin, meaning navel of the world, a name that carries more weight than most tourists realize as they climb the narrow trail carved into its western face. Lewis and Clark noted it in their journals as a landmark visible from 20 miles away, but they never mentioned what park rangers would document 2 centuries later: the rock's peculiar relationship with sound. The Columbia River Gorge funnels wind between the Cascade Mountains with such force that it creates its own weather patterns. Beacon Rock sits at the heart of this natural wind tunnel, where the constant rush of air through basalt cliffs produces a low, omnipresent hum that locals have learned to tune out. The trail to the summit, completed in 1918 by Henry Biddle, winds around the rock's circumference through a landscape that seems designed to amplify every footstep, every whispered conversation, every rustle of fabric against stone. Park rangers describe Beacon Rock as acoustically predictable. Sound carries differently here than in flatter terrain. Voices seem to hang in the air longer, and echoes bounce between the rock face and the river below in ways that create unexpected harmonics. Climbers often comment on how their conversations seem to follow them up the trail, words spoken at the base somehow reaching their ears again near the summit. It's the kind of place where sound has weight and presence, where silence would be impossible under normal circumstances. But normal circumstances, according to 7 years of incident reports, don't always apply. The first documented silence occurred on August 15, 1987. Dr. Margaret Chen, a geologist from the University of Washington, was conducting a routine survey of the rock's eastern face when she noticed her equipment had stopped registering ambient noise levels, not reduced levels, 0 readings across all frequencies. Chen initially suspected equipment failure until she realized she could no longer hear the Columbia River flowing below, the constant wind through the gorge, or even her own breathing. "I thought I'd gone deaf," Chen wrote in her field notes, which were later submitted to the Washington State Parks Commission. "But I could hear my heartbeat, and when I spoke, my voice sounded normal to me. It was everything else that had stopped. The river, the wind, the birds, nothing. For 17 minutes, the world went quiet, except for what was happening inside my body." Chen's report might have been dismissed as an isolated incident, if not for what happened exactly 1 year later. On August 15, 1988, hikers Jerry Watanabe and Susan Morrison experienced an identical phenomenon while approaching the summit trail. Both were experienced climbers familiar with the rock's usual acoustic properties. Both noted the exact same duration: 17 minutes of absolute environmental silence, beginning at approximately 2:30 in the afternoon. "It wasn't just quiet," Morrison told park officials during her formal statement. "Quiet still has presence. This was absence, like someone had turned off the soundtrack to the world, but only for everything that wasn't us." Watanabe's account included details that would become disturbingly familiar in subsequent reports. During the silence, he became increasingly aware of his own internal sounds: pulse, breathing, the movement of saliva in his mouth. But more unsettling was what he described as hearing my thoughts before I thought them, like an echo running backward. The phenomenon repeated with mechanical precision each August 15 through 1994, always lasting exactly 17 minutes. Always beginning between 2:15 and 2:45 in the afternoon. Always affecting only environmental sounds, while leaving human-generated noise unaffected. Park records show that 23 separate individuals or groups experienced what staff began privately calling the silence events. Dr. Harold Reeves, a sound engineer who visited the site in 1990, brought professional audio equipment to document the phenomenon. His recordings from August 15th of that year show normal ambient levels building to the expected decibel range for the location, then dropping to zero across all frequencies for exactly 17 minutes before resuming as if nothing had happened. The recording equipment itself functioned normally. Voices, footsteps, and equipment sounds register clearly throughout. Only the environmental audio disappears. We're looking at selective acoustic dampening that affects specific sound sources while leaving others completely unaffected, Reeves noted in his unpublished report. This suggests either a highly sophisticated technological intervention or a natural phenomenon that operates according to principles we don't understand. What disturbed Reeves more than the technical impossibility was the psychological effect on witnesses. Of the 16 people he interviewed, 12 reported lasting anxiety about the experience. 3 sought counseling. 1. A Forest Service employee named David Kim took early retirement after the 1991 event and moved to Eastern Oregon. They all described the same thing, Reeves observed. During the silence, they become hyper-aware of their own biological processes, but they also report hearing what they describe as wrong echoes, their own thoughts, but delayed and somehow altered. Several mentioned feeling like their mental processes were being monitored or recorded. Kim's written statement, filed with the Park Service 3 weeks after his experience, provides the most detailed account of the psychological effects. For 17 minutes, I could hear my heartbeat, like it was coming from outside my chest. My breathing sounded like it was happening in a different room. And underneath all of that, I could hear myself thinking. But the thoughts came back to me a split second later, and they weren't quite the same thoughts I remembered having. The Washington State Parks Commission opened a file on the Beacon Rock incidents in 1991, but the investigation consisted primarily of interviewing witnesses and ruling out equipment malfunctions. No scientific studies were commissioned. No acoustic specialists beyond Reeves examined the site. The file was quietly closed in 1995 with a notation that the phenomenon had ceased to recur and posed no ongoing threat to public safety. State geologist Patricia Holbrook, who reviewed the case file in 1996, found the official response insufficient. Her request to conduct a comprehensive geological and acoustic survey of the area was denied due to budget constraints. Holbrook's follow-up inquiries were referred to the State Attorney General's office, where they remained unanswered. Something that's specific and regular doesn't just stop, Holbrook said in a 2003 interview with a regional newspaper. 17 minutes, same date, same time window, 7 consecutive years. Natural phenomena don't operate with that kind of precision. Someone should have been asking why it started and why it stopped. The silence event ceased after August 15, 1994. Park rangers noted the date in their logs, but no formal investigation was conducted into why the phenomenon had ended. Visitors continued to climb Beacon Rock without incident. The trail remained popular. The acoustic properties of the gorge returned to their predictable patterns, but those who experienced the silence carried something away with them. Follow-up interviews conducted by a private researcher in 2007 found that 11 of the original 23 witnesses had developed what they described as sound sensitivity, and heightened awareness of ambient noise and an acute discomfort with sudden silence. 2 had moved away from the Pacific Northwest entirely. 5 reported recurring dreams about standing on the rock during an impossible eternal quiet. Dr. Chen, the geologist whose 1987 report first documented the phenomenon, declined to be interviewed. Her assistant at the University of Washington confirmed that she no longer conducts fieldwork in the Columbia River Gorge and has never published research related to her Beacon Rock findings. Today, Beacon Rock attracts thousands of hikers annually. The trail to the summit remains one of Washington's most popular short climbs. Park literature describes the rock's geological significance and historical importance, but makes no mention of the acoustic anomalies documented in the late 1980s and early 1990s. The state parks file on the Beacon Rock incidents was transferred to deep storage in 2001 and listed as archived pending technological advancement in acoustic analysis. No such advancement has prompted its retrieval. The 23 people who experienced 17 minutes of impossible silence have learned to keep their voices low when they speak of what they heard in the quiet, or more precisely, what the quiet helped them hear about themselves. Beacon Rock continues to rise above the Columbia River, catching morning light and evening shadow the same way it has for millennia. The wind still rushes through the gorge with relentless force. The trail still carries voices upward and echoes downward, but those who climbed it during 7 specific August afternoons know that some silences are not absences, they're presences waiting to be recognized. Some records keep themselves. The Deception Pass Bridge connects Whidbey Island to Fidalgo Island across a narrow channel where Puget Sound meets the Strait of Juan de Fuca. Built in 1935 during the height of the Depression, the twin cantilever spans rise 180 feet above waters that rush between the islands, with tidal forces powerful enough to create standing waves. The Civilian Conservation Corps workers who built the bridge noted the unusual density of the local stone, a basalt formation that proved almost too hard to work with conventional tools of the era. The bridge carries State Route 20 across what Captain George Vancouver named Deception Pass in 1792, mistaking the narrow waterway for a bay. The name proved prophetic in ways Vancouver could never have anticipated. The pass creates optical illusions, where the water appears to flow uphill during certain tidal conditions, and ships' compasses have historically shown minor but consistent deviation when navigating the channel. Local Swinomish tribal members avoided the area long before European contact, referring to it in their oral traditions as the place where the water counts what crosses above it. Early settlers dismissed this as folklore, but maritime records from the 1800s document an unusually high number of navigation errors in the vicinity, with ships' logs noting discrepancies between dead reckoning and actual position that couldn't be explained by current or wind patterns. The Washington State Department of Transportation conducts routine underwater inspections of the bridge, supports every 5 years using divers and sonar equipment. These inspections focus on structural integrity, checking for cracks, erosion, or damage that could compromise the span's stability. The work is methodical and unglamorous. Teams of engineers and divers, documenting the condition of concrete and steel that most travelers never consider as they cross overhead. On September 22, 2011, diver Michael Santos made a discovery that would remain classified in state maintenance files for the next 7 years. Santos was conducting a standard visual inspection of the bridge's eastern foundation when his underwater lights revealed what appeared to be surface irregularities on the stone pier. The markings were invisible from more than 3 feet away, etched into the basalt with precision that Santos initially attributed to natural weathering patterns. Only when he examined the stones through a magnifying lens did he realize the weathering consisted of text. "I thought it was vandalism at first," Santos reported to his supervisor, structural engineer Patricia Voss. "Kids with some kind of acid etching tool, maybe." But the marks went down below the low tide line, in places where you'd need diving equipment to reach. And the text was so small, I could barely read it with a magnifying glass. Santos photographed the markings and returned to the surface, where Voss examined the images on waterproof tablets. The text appeared to be numbers arranged in columns, interspersed with what looked like dates. The precision of the etching was remarkable. Each character measured less than 2 millimeters in height, carved with uniform depth and spacing that suggested mechanical rather than human creation. Voss authorized a more detailed inspection the following week. Santos and a second diver, Elena Rodriguez, spent 4 hours documenting the full extent of the markings. They covered 3 of the 4 main support pillars and extended from just above the foundation to approximately 10 feet below the lowest tide level. The text was organized in a grid pattern, with dates running vertically and numbers running horizontally. Rodriguez, who had experience with historical preservation, recognized the date format as corresponding to the American standard used since the early 20th century. The earliest date she could identify was January 15th, 1935, 2 weeks after the bridge opened to traffic. It was like reading a logbook, Rodriguez later told investigators from the Washington State Patrol. Each date had a number next to it. Some days showed 0, others showed double digits. There was a clear pattern: higher numbers on weekends, lower numbers on weekdays, just like you'd expect from traffic volume. The implications became clear when Voss compared the carved numbers with historical traffic data from the state archives. The Department of Transportation had maintained vehicle counts for the Deception Pass Bridge since 1952, using mechanical counters and later electronic sensors. Where the records overlapped, the numbers carved in stone matched the official counts exactly. But the stone records went back 17 years before the state began keeping electronic tallies, and they included data for every single day since the bridge opened, with no gaps or inconsistencies. The precision was absolute, not estimated daily totals or rounded figures, but exact counts that included single vehicle discrepancies that wouldn't show up in typical traffic monitoring. Dr. James Mitchell, a forensic geologist from the University of Washington, examined samples of the carved stone in late 2011. His analysis revealed that the etching had been done with a tool capable of maintaining consistent depth and width across thousands of individual characters. The tool marks showed none of the variation typical of hand carving, and the stone showed no signs of recent disturbance around the carved areas. The etching appears to have been done when the stone was quarried, Mitchell noted in his preliminary report. But that would place the creation of these markings in 1934, before the bridge was built, before there was any traffic to count. Mitchell's analysis revealed another impossibility. The carved numbers continued beyond the historical record, listing daily vehicle counts for dates that had not yet occurred when Santos first discovered them. The entries extended exactly 3 days into the future from the date of discovery, terminating with an entry dated September 25, 2011, that contained a single word instead of a number: 0. The Washington State Patrol opened an investigation into potential vandalism or fraud, but found no evidence of human intervention. The area around the bridge foundations showed no signs of disturbance. Security cameras installed after 9/11 had no record of unauthorized access to the underwater sections of the bridge. The carved text appeared to have existed exactly as Santos found it. State archivists researched the construction records from the original bridge project, looking for any mention of commemorative inscriptions or decorative elements that might explain the carvings. The Civilian Conservation Corps kept detailed records of their work, including daily progress reports and material inventories. No documents mentioned text, numbers, or any kind of inscription work on the stone supports. More troubling was what happened on September 25, 2011. The date marked 0 in the stone records. At approximately 3:15 in the morning, the electronic traffic monitoring system for the Deception Pass Bridge went offline. The system had functioned without interruption for 8 years, but on that date, it recorded no vehicle crossings for a period of exactly 17 minutes. State transportation officials attributed the outage to a software malfunction and restored service by 4:30 that morning. Routine maintenance logs show no mechanical problems with the monitoring equipment, and backup power systems functioned normally throughout the incident. The 17-minute gap was classified as an anomalous data loss event and filed without further investigation. Dr. Mitchell submitted a request to expand his geological analysis of the bridge supports, but the Washington Department of Transportation denied permission, citing safety concerns and budget limitations. Mitchell's follow-up requests were referred to the State Attorney General's office, where they remain pending review. The underwater inscriptions were photographed extensively during the 2011 inspection, but those images were classified as part of ongoing infrastructure security assessments. Santos and Rodriguez signed non-disclosure agreements related to their findings, standard procedure for sensitive infrastructure inspections. Public records requests for the bridge inspection files have been denied under exemptions for critical infrastructure protection. In 2016, routine sonar mapping of the bridge supports revealed that the carved text now extends to sections of stone that were previously unmarked. The new inscriptions follow the same format as the original discovery, dates and numbers arranged in precise columns. The most recent entry, according to divers who have seen the updated carvings, is dated exactly 3 days in the future from whenever the inspection occurs. The traffic monitoring system for the Deception Pass Bridge continues to experience periodic data loss events, always lasting exactly 17 minutes, always occurring in the early morning hours. The Washington State Department of Transportation has replaced the monitoring equipment twice since 2011, but the outages persist with mechanical regularity. Today, approximately 6 million vehicles cross the Deception Pass Bridge annually. The state maintains detailed traffic statistics for planning and maintenance purposes, using multiple redundant counting systems that provide precise daily totals. But somewhere beneath the dark waters of the pass, older records continue to accumulate in stone, keeping a count that began before anyone thought to ask what was being counted or why the counting would ever need to stop. The bridge stands as it has for nearly 90 years, carrying travelers between the islands while the water below rushes through the pass with forces that have carved channels through solid rock. But the stones remember everything that crosses above them, marking each passage with a precision that suggests someone or something has always been keeping score. Some paths refuse to be measured twice the same way. The Sol Duc Valley cuts deep into the heart of the Olympic Mountains, a glacially carved corridor where ancient forests meet alpine meadows beneath peaks that rise over 7,000 feet. The valley's name derives from the Quileute phrase meaning sparkling water, though early logging operations in the 1920s gave it a different reputation among workers who complained that the terrain seemed to shift between surveys, making accurate timber estimates impossible. Olympic National Forest encompasses nearly 630,000 acres of temperate rainforest, subalpine meadows, and rugged mountain terrain. The Sol Duc region became part of the National Forest System in 1909, but remained largely inaccessible until the Civilian Conservation Corps built the first maintained trails in the 1930s. These trails followed ancient elk paths and indigenous routes that had been used for centuries, winding through old-growth Douglas fir and western hemlock toward high country lakes and thermal springs. The Forest Service began systematic trail mapping in the 1950s using standard surveying techniques, compass bearings, chain measurements, and triangulation from known landmarks. The work was methodical and precise, following protocols developed by the U.S. Geological Survey for wilderness cartography. Teams would walk each trail multiple times, measuring distances with steel chains and recording elevation changes with barometric instruments. By 1962, the Sol Duc Trail system had been mapped and remapped 6 times by different survey crews. The maps showed consistent discrepancies that cartographers initially attributed to measurement error or magnetic declination variations. But the errors followed a pattern that shouldn't have been possible. Every trail that ran primarily east to west showed different measured distances depending on the direction of travel. Forest Service cartographer William Hayes documented the first official recognition of what he termed directional distance variance in his 1963 report to the regional office in Portland. Hayes had supervised 3 separate survey teams on the Sol Duc River Trail, a well-established path that connected the ranger station to Sol Duc Hot Springs. Using identical equipment and techniques, Each team measured the trail as exactly 4.7 miles when walking from east to west, but only 4.4 miles when walking from west to east. We checked our instruments, recalibrated our chains, and verified our compass readings against known benchmarks. Hayes wrote in his report, "The measurements are consistent and repeatable. The trail is demonstrably longer in one direction than the other, which contradicts basic principles of linear measurement." Hayes requested permission to bring in professional surveyors from the U.S. Geological Survey to resolve what he assumed was a systematic error in Forest Service methodology. The request was approved, and in August 1964, a team led by surveyor Daniel Morrison conducted a comprehensive measurement of 5 Sol Duc Valley trails using precision instruments normally reserved for boundary surveys. Morrison's team used steel tapes accurate to within 1 inch per mile, electronic distance measuring equipment, and transit theodolites for angular measurements. They established permanent markers along each trail and measured distances between fixed points to eliminate variables related to pathfinding or route interpretation. The results confirmed Hayes's findings with uncomfortable precision. Every trail that ran predominantly east to west showed the same discrepancy, 0.3 miles longer when measured from east to west than from west to east. North-south trails showed no variance. Trails that changed direction multiple times showed variable discrepancies that corresponded exactly to their westward segments. "The measurements are accurate and reproducible," Morrison reported to the U.S. Geological Survey. In September 1964, "We have verified our instruments against known baselines and found no systematic errors. The discrepancy appears to be a property of the terrain itself, not our measurement techniques." Dr. Margaret Lindstrom, a physicist from the University of Washington, was contracted to review Morrison's data and propose explanations for the anomalous measurements. Lindstrom's analysis, completed in early 1965, explored possibilities ranging from gravitational variations to magnetic field effects, but found no known physical phenomena that could account for directional distance variance of this magnitude. Local hikers had been noticing the effect for years without understanding its significance. Tom Brennan, a fishing guide who had worked the Sol Duc Valley since the 1940s, told Hayes that he'd always allowed extra time when guiding clients westward on familiar trails. "I thought I was just getting older and walking slower," Brennan said in a recorded interview from 1965. "But clients would complain about the hike taking longer than I'd promised, even when we kept a steady pace. It was always the trips heading toward the hot springs that ran long, never the return trips." Brennan's clients included experienced hikers who had noticed the time discrepancy as well. Dr. Sarah Chen, a botanist who conducted research in the valley during the 1960s, kept detailed field notes that included travel times between study sites. "I would start from the ranger station at 8 in the morning and reach my plots at the hot springs by noon, a 4-hour hike that should have covered 4.4 miles according to the maps," Chen recalled in a 1998 interview. "But when I walked back the same afternoon, covering what should have been the same 4.4 miles, I'd reach the ranger station in 3.5 hours. I assumed the return trip felt faster because I was familiar with the route, but my pedometer readings were consistently different." More unsettling were the psychological effects reported by hikers who became aware of the distance discrepancy. Chen described feeling temporarily unmoored during westward hikes, as if time itself was being stretched along with the trail. "Once I realized the distance was different depending on direction, I couldn't stop thinking about it while walking," Chen said. "It felt like I was walking through extra space that wasn't supposed to be there, like the forest was borrowing length from somewhere else and would eventually have to give it back." The Forest Service conducted additional surveys in 1966 and 1968, both confirming the original measurements. Regional administrators requested an explanation from the National Bureau of Standards, which declined to investigate, citing the phenomenon as outside the scope of standard measurement protocols. Dr. Lindstrom's 1965 report remained the only scientific analysis of the Sol-Duc measurements until 1973, when she published a brief paper in the Journal of Applied Physics, noting the discrepancies and calling for further research. The paper generated no follow-up studies, and Lindstrom's subsequent grant applications to study the phenomenon were consistently denied. In 1975, the Forest Service implemented new trail mapping procedures that standardized distance measurements to eliminate directional variance reporting. The new protocols required surveyors to average eastward and westward measurements for all official trail documentation, effectively erasing the discrepancy from public maps. Hayes, who had first documented the anomaly, was transferred to a desk position in the regional office and later took early retirement. Morrison's surveying team was reassigned to different national forests, and their detailed measurement records were archived under geographic anomaly classifications that restricted public access. The archive files reveal that the directional distance variance was not unique to the Sol-Duc Valley. Between 1964 and 1974, Forest Service teams documented similar discrepancies in 11 other locations across Washington's Olympic Peninsula, all showing the same 0.3-mile variance on east-west trails. Dr. Chen continued her botanical research in the Sol-Duc Valley through the 1980s, but stopped discussing the distance anomaly after receiving what she described as informal guidance from Forest Service administrators about maintaining scientific objectivity in her published research. I was told that reporting measurement discrepancies without peer-reviewed explanations could undermine public confidence in Forest Service trail information, Chen said. The implication was that my research permits might not be renewed if I continued to publicize anomalous findings. GPS technology, introduced to Forest Service mapping in the 1990s, initially appeared to resolve the Sol-Duc measurement discrepancies. Satellite positioning showed consistent distances regardless of travel direction, matching the averaged measurements that had become standard in official documentation. But hikers using personal GPS devices began reporting a different anomaly. Their units would show travel times that didn't match distance calculations when walking westward on Sol-Duc trails. The devices recorded accurate positions and elevations, but calculated travel speeds that suggested hikers were covering more ground than the GPS distances indicated. Forest Service officials declined to comment on GPS anomalies, citing the unreliability of consumer-grade positioning devices in mountainous terrain. Public inquiries about historical trail measurement discrepancies are referred to archived files that remain restricted under administrative review. The Sol-Duc Valley continues to attract thousands of hikers annually, drawn by its hot springs, waterfalls, and old-growth forests. Trail guides provide standard distance estimates based on official Forest Service measurements, but experienced guides still quietly add extra time to westward itineraries, following protocols they've learned through practice rather than documentation. The trails wind through the same ancient forests, where early loggers complained about shifting terrain, and indigenous peoples marked seasonal routes that seemed to change length with the direction of travel. Hikers walk these paths without knowing that their westward steps cover 0.3 miles more distance than their eastward, returns extra space that maps don't acknowledge and instruments can't explain, but boots and time continue to measure with disturbing consistency. Some signals arrive before they're sent. The Blue Mountains rise along the border between Washington and Oregon, a range of peaks and plateaus that extend from the Cascade foothills eastward into the Columbia Plateau. The region earned its name from the blue-tinged atmospheric haze that settles over the ridges during summer months, created by the interaction of mountain thermals with moisture from the distant Pacific. Early telegraph lines avoided the area due to persistent signal interference that operators attributed to iron ore deposits and unusual atmospheric conditions. The mountains harbor remnants of mining operations from the late 1800s, when prospectors followed rumored gold strikes into remote valleys that often proved barren. Most of these operations were abandoned by 1910, leaving behind scattered equipment and mine shafts that honeycomb the higher elevations. The terrain is rough and sparsely populated, with vast expanses of pine forest broken by rocky outcrops and alpine meadows that remain snow-covered well into summer. Walla Walla County extends into the northern reaches of the Blue Mountains, encompassing territory that has always challenged conventional communication technology. Early radio operators in the 1920s reported unusual propagation effects in the area, signals that seemed to originate from empty mountainsides and transmissions that arrived with impossible clarity from locations where no radio equipment was known to exist. The phenomenon that would become known as the Blue Mountain Transmission was first documented by amateur radio operator Frank Morrison on June 12, 1978. Morrison operated station W7QRX from his home near Dayton, Washington, conducting routine evening communications with other operators across the Pacific Northwest. He maintained detailed logs of all contacts, recording call signs, frequencies, signal strengths, and atmospheric conditions that might affect propagation. Morrison's logs from the 1970s show the methodical precision of an experienced operator who understood the technical aspects of radio communication. On the evening of June 12th, while scanning the 40-meter amateur band, Morrison detected a strong signal on 14.215 MHz that didn't match any known station. The signal consisted of a continuous weather report, delivered in clear, unaccented English by what sounded like a professional broadcaster. The content was unusual detailed meteorological observations for a date 5 days in the future. The transmission described weather conditions for June 17, 1978. Morrison wrote in his station log, "Perfect clarity, 62 degrees at sunrise. Light winds from the southwest. Visibility unlimited. No precipitation." The report was extremely detailed, barometric pressure, humidity levels, dew point calculations, all for a specific date that hadn't happened yet. Morrison used direction-finding equipment to triangulate the signal's origin, a standard procedure for identifying unknown transmissions. His bearings consistently pointed to coordinates in the Blue Mountains approximately 40 miles southeast of his location. According to topographical maps, the signal appeared to originate from a point on Battle Creek Ridge at an elevation of 4,200 feet, an area of exposed bedrock with no structures, roads, or power lines. The transmission repeated exactly every 12 minutes for 3 hours, then ceased abruptly at 11:47 p.m. Morrison attempted to contact other amateur operators to verify the signal, but found that none of them could receive the transmission, despite having equipment capable of detecting much weaker signals from greater distances. When June 17th arrived, Morrison compared the transmitted weather forecast with actual conditions in the Blue Mountain region. The forecast proved accurate in every detail. Temperature, wind direction, barometric pressure, and visibility matched the predictions exactly, despite the fact that regional weather services had forecast light rain and overcast skies for that date. Morrison reported the incident to the Federal Communications Commission, providing copies of his logs and direction-finding data. The FCC acknowledged receipt of his report but took no investigative action, noting that amateur radio operators occasionally receive reflected signals from distant stations under unusual atmospheric conditions. The transmission returned on July 14, 1978, following the same pattern, a detailed weather forecast for 5 days in the future, originating from the same coordinates, repeating every 12 minutes for exactly 3 hours. Morrison recorded the transmission and invited 2 other local amateur operators, Robert Chen and Patricia Wells, to monitor the frequency. Chen and Wells both detected the signal, confirming Morrison's direction-finding results and the accuracy of the weather predictions. Chen, who had experience with military communications equipment, noted that the signal's strength suggested a transmitter power of at least 1,000 watts, far more than typical amateur radio equipment, and requiring substantial electrical infrastructure. The signal was coming through like a local station, Chen reported in a letter to the American Radio Relay League. But there's nothing at those coordinates except rocks and trees. No power lines, no buildings, no access roads. We're talking about a location that would require helicopter access just to reach, and the terrain is too steep to support a tower or antenna system. Wells, a licensed engineer who worked for the local power company, researched the electrical infrastructure in the Battle Creek Ridge area and confirmed that no power lines extended to the transmission coordinates. The nearest electrical service was over 12 miles away, making it impossible to operate high-powered radio equipment without a generator or battery system that would require regular maintenance and fuel delivery. The three operators monitored the frequency throughout the summer and fall of 1978, documenting 15 separate transmissions that followed the same pattern. Each transmission provided accurate weather forecasts for 5 days in the future, always describing perfect weather conditions identical to those predicted in the first transmission Morrison had received. Dr. James Mitchell, a physics professor at Washington State University, reviewed the operator's documentation at Chen's request in early 1979. Mitchell's analysis focused on the technical aspects of the radio propagation and the unusual consistency of the weather predictions. The signal characteristics suggest a conventional AM transmission originating from a fixed location, Mitchell noted in his report. But the coordinates correspond to solid bedrock, approximately 400 feet below ground level. There is no known technology that would allow a radio transmitter to operate from that location, and no geological formation that would facilitate signal propagation from underground sources. Mitchell's attempts to verify the phenomenon were complicated by the sporadic nature of the transmissions. Despite monitoring the frequency with sensitive equipment during predicted transmission times, he was unable to detect the signal. The transmissions appeared to be audible only to the original three operators, despite using identical equipment and monitoring from nearby locations. The FCC conducted a field investigation in May 1979, sending a team of engineers to the Blue Mountain region to locate the source of what they classified as an unlicensed transmission. The investigation team used professional direction-finding equipment and conducted aerial surveys of the suspected transmission area, but found no evidence of radio equipment, antenna systems, or electrical infrastructure. The FCC team did discover something that complicated their investigation. The coordinates identified by Morrison, Chen, and Wells as the transmission source corresponded to the location of an abandoned gold mine shaft that descended approximately 400 feet into the bedrock of Battle Creek Ridge. The mine, known as the Prospect Creek Diggings, had been excavated in 1897 and abandoned 2 years later when no commercially viable ore was found. Mining records from the Washington State Department of Natural Resources showed that the Prospect Creek shaft had been sealed with timber and rock in 1923 as part of a safety initiative to prevent accidents at abandoned mine sites. Geological surveys indicated that the shaft extended straight down through granite bedrock to a depth that would place its bottom at exactly the coordinates calculated for the radio transmission source. FCC engineers theorized that the sealed mine shaft might be acting as a natural antenna or resonating cavity that could amplify or redirect radio signals from distant transmitters. This explanation would account for the strong signal strength and consistent direction-finding results, but it didn't address the accuracy of the weather predictions, or why only certain operators could receive the transmissions. Dr. Mitchell requested permission to conduct acoustic and electromagnetic studies of the sealed mine shaft, but was denied access by the Washington State Department of Natural Resources, which cited safety concerns and environmental protection regulations. His subsequent appeals were referred to the State Attorney General's office, where they remained under review. The Blue Mountain transmissions continued through 1981, always following the same pattern. but becoming increasingly difficult to detect. Morrison reported that the signal strength was gradually declining, as if the transmitter power was being reduced or the antenna system was deteriorating. By 1982, only Morrison could consistently receive the transmissions, and the audio quality had degraded significantly. The final documented transmission occurred on September 23, 1982. Morrison recorded a weather forecast for September 28th that described the same perfect conditions that had been predicted in all previous transmissions. When September 28th arrived, the weather matched the forecast exactly, but no further transmissions were detected from the Blue Mountain coordinates. FCC files on the Blue Mountain investigation were classified in 1983 and remain restricted under regulations governing radio frequency allocation and national security communications. Morrison's detailed logs were transferred to federal custody as part of the classification process, though copies were retained by the American Radio Relay League's technical archives. Morrison continued monitoring the 14.215 MHz frequency until his death in 2006, but never again detected transmissions from the Battle Creek Ridge coordinates. Chen and Wells relocated to other states in the mid-1980s, and their current whereabouts are unknown. Today, the Battle Creek Ridge area remains as remote and inaccessible as it was during the 1970s. The sealed Prospect Creek mine shaft is marked on geological survey maps, but is not accessible to the public. Modern amateur radio operators occasionally report unusual propagation effects in the Blue Mountains, but none have documented the systematic weather forecasting that characterized the original transmissions. The perfect weather conditions described in the Blue Mountain transmissions, 62 degrees at sunrise, light southwest winds, unlimited visibility, represent meteorological conditions that occur naturally in the region, perhaps 3 or 4 times per decade. But for 4 years in the late 1970s and early 1980s, those conditions were predicted with absolute accuracy by a voice that spoke from 400 feet underground, describing a future that always arrived exactly as promised, broadcasted from a place where no transmitter could exist, and powered by energy that left no trace of its source. Some mornings refuse to arrive on schedule. The Mount Baker Snoqualmie National Forest encompasses 1.7 million acres of Cascade Mountain wilderness, stretching from the Canadian border south to Mount Rainier. Heather Meadows sits at 4,200 feet elevation on the southern slopes of Mount Baker, a subalpine zone where wildflower meadows give way to permanent snowfields and glacial crevasses. The area became accessible to civilian visitors in 1927 when the Mount Baker Highway reached completion, but the high elevation and harsh winter conditions limit the camping season to a few months each summer. The meadows earned their name from the purple heather that blooms across the landscape each August, creating carpets of color that attract photographers and botanists from across the Pacific Northwest. Early visitors noted the unusual quality of light at Heather Meadows, a clarity and intensity that seemed to enhance colors and sharpen distant views in ways that defied the typical atmospheric conditions of high altitude. Locations. The U.S. Weather Bureau established a seasonal observation station at Heather Meadows in 1952, primarily to monitor conditions for the nearby Mount Baker ski area. The station operated from June through September each year, staffed by meteorologists who recorded standard observations, temperature, precipitation, wind speed, and atmospheric pressure. Among these routine measurements was the precise timing of sunrise and sunset data required for calculating daylight hours and solar radiation levels. Meteorological sunrise is defined as the moment when the upper edge of the sun becomes visible above the eastern horizon, as observed from a specific location and elevation. The timing can be calculated with extreme precision, using astronomical formulas that account for the Earth's rotation, orbital position, and atmospheric refraction. For any given date and location, Sunrise should occur within seconds of the calculated time, barring unusual atmospheric conditions. On June 21, 1979, weather observer Martin Rodriguez recorded the summer solstice sunrise at Heather Meadows as occurring at 5:47 a.m., 18 minutes later than the calculated time of 5:29 a.m. Rodriguez initially attributed the delay to thick cloud cover on the eastern horizon, but his notes indicate clear skies and unlimited visibility at the time of observation. "I checked my chronometer against the radio time signal twice that morning," Rodriguez wrote in his observation log. The sunrise was definitely delayed, but there was no atmospheric obstruction that would account for the difference. The sun simply appeared to rise 18 minutes behind schedule. Rodriguez reported the discrepancy to the regional weather office in Seattle, expecting guidance on how to record anomalous observations. The response instructed him to record sunrise times according to astronomical calculations rather than actual observations, noting that instrument error or atmospheric effects likely accounted for the timing difference. But the 18-minute delay persisted throughout the summer of 1979, affecting every sunrise Rodriguez observed from the Heather Meadows station. His personal notes, discovered in Weather Service archives decades later, show increasing frustration with instructions to record calculated, rather than observed, sunrise times. Day 47 of delayed sunrise, Rodriguez wrote on August 7, 1979. The pattern is absolutely consistent. Every morning, the sun appears exactly 18 minutes late. I verified my instruments against multiple time sources. The delay is real, but headquarters insists on recording theoretical sunrise times. Dr. Patricia Chen, an astronomer from the University of Washington, visited Heather Meadows in August 1979 to investigate reports of unusual lighting conditions that photographers had been discussing in regional camera clubs. Chen brought precision timing equipment and conducted her own sunrise observations over a 5-day period. "I confirmed Rodriguez's measurements," Chen noted in her field journal. "The sun consistently appeared 18 minutes later than astronomical calculations predicted. But what was more disturbing was the quality of those 18 minutes before sunrise. The sky showed the normal progression of dawn colors. The horizon lightened, stars faded, the eastern sky brightened, but no sun appeared until 18 minutes past the calculated time." Chen's observations included detailed notes about the pre-sunrise period that would become central to later investigations. During the 18-minute delay, the sky exhibited all the visual characteristics of approaching sunrise: graduated color changes, increasing ambient light, and the normal celestial mechanics of dawn. But the sun itself remained absent, as if the dawn was proceeding independently of the solar disk. Campers at nearby Picture Lake and the Mount Baker Lodge began reporting unusual experiences during what they learned to call the missing minutes. David Morrison, a regular visitor to Heather Meadows since the 1960s, described the phenomenon in a letter to the Forest Service. "You'd wake up expecting sunrise, and the sky would start getting light right on schedule," Morrison wrote. "But then you'd wait, and the sun just wouldn't come up. It felt like time was moving wrong, like those 18 minutes were being stretched out longer than they should be. Some mornings, I'd look at my watch and swear it had stopped. But when the sun finally appeared, the time was exactly what you'd expect, if everything had been normal." Sarah Williams, a botanist who conducted research at Heather Meadows during the early 1980s, reported similar temporal distortions. Her field studies required precise timing for measuring plant responses to changing light conditions, and she became acutely aware of the sunrise delays. "I would set up my equipment based on calculated sunrise times, then wait 18 minutes for actual sunrise," Williams recalled in a 1997 interview. "During those 18 minutes, I felt like I was existing in borrowed time, like the universe was running behind schedule and trying to catch up. My wristwatch would tick normally, but the minutes felt interminable." More disturbing were reports from campers who described psychological effects during the delayed sunrise period. Tom Bradley, who managed the Mount Baker Lodge from 1978 to 1985, kept informal records of guest complaints about sleep disturbances and anxiety during the summer months. People would wake up before dawn feeling fine, then become increasingly agitated as the minutes passed without sunrise, Bradley noted. They described feeling like they were waiting for something that might never happen, even though they knew the sun would eventually rise. Some guests cut their stays short because they couldn't tolerate what they called the waiting time. The National Weather Service conducted an internal review of the Heather Meadows observation discrepancies in 1980, sending a team of meteorologists to verify Rodriguez's measurements and equipment. The review team confirmed the 18-minute sunrise delays, but attributed them to localized atmospheric effects and observer error related to high-altitude conditions. Dr. James Mitchell, a physicist specializing in solar observation, was contracted to provide an independent analysis of the Heather Meadows data. Mitchell's report, completed in November 1980, acknowledged the consistent measurement discrepancies, but found no known atmospheric phenomenon that could delay apparent sunrise by exactly 18 minutes, while leaving all other celestial observations unaffected. The measurements are accurate and repeatable, Mitchell concluded, but they describe an impossible situation: a sunrise that occurs 18 minutes after the sun should be visible, preceded by a dawn sequence that proceeds normally in all respects except for the absence of the solar disk. No known optical or atmospheric effect can account for this pattern. Mitchell's report was classified by the National Weather Service and filed under atmospheric anomaly designations that restricted public access. His request to establish a specialized observation program at Heather Meadows was denied due to budget constraints and conflicting research priorities. The sunrise delays continued through the summer of 1983, always maintaining the exact 18-minute discrepancy. Rodriguez completed his final season at Heather Meadows that year and was transferred to a weather station in eastern Washington. His replacement, Jennifer Walsh, was instructed to record only calculated sunrise times and not to document observational discrepancies. In 1984, Walsh reported that sunrise observations at Heather Meadows matched astronomical calculations within normal margins of error. The 18-minute delays had ended as abruptly as they had begun, with no transition period or gradual correction. Official Weather Service records show no acknowledgement of the discrepancy period or explanation for its resolution. Dr. Chen attempted to return to Heather Meadows in 1985 to investigate the cessation of the sunrise anomaly, but was denied research permits by the Forest Service. Her subsequent inquiries were referred to the National Weather Service, which declined to provide access to historical observation data from the Heather Meadows station. Rodriguez's personal observation logs were discovered in 1998 during an archive consolidation project, but were immediately reclassified and transferred to restricted storage. Freedom of Information Act requests for Weather Service records from the Heather Meadows station during the 1979 to 1983 period have been denied under exemptions for meteorological, security, and ongoing atmospheric research. Walsh continued as the Heather Meadows Weather Observer through 1991, but her logs from that period contain no references to unusual sunrise timing or atmospheric anomalies. Campers and visitors to the area reported normal dawn conditions throughout the 1980s and beyond. Today, Heather Meadows attracts thousands of visitors each summer, drawn by its spectacular mountain views and abundant wildflowers. Sunrise from the Meadows is considered one of the premier photographic opportunities in the North Cascades, with the timing predictable to within minutes using standard astronomical calculations. But those who experienced the stretched mornings of the early 1980s carry a different understanding of dawn at high altitude. They remember waiting through 18 minutes that felt like hours, watching the sky lighten in preparation for a sun that refused to appear on schedule, existing in time that seemed borrowed from somewhere else and eventually returned without explanation. The meteorological station at Heather Meadows continues to record standard weather observations each summer, including precise sunrise and sunset times that match astronomical predictions with clockwork regularity. But somewhere in restricted government archives, 5 years of impossible mornings remain documented 18-minute delays that stretch the boundary between day and night, creating pockets of unrecorded time that existed only in the memories of those who waded through them. Some trees keep records of seasons they never witnessed. Mary Hill sits on a wind-scoured plateau above the Columbia River, where the high desert of eastern Washington meets the basalt cliffs of the Columbia Gorge. The area takes its name from entrepreneur Sam Hill, who began construction of a utopian Quaker community here in 1907. Hill's vision of a flourishing agricultural settlement never materialized, leaving behind only scattered foundations and the incongruous replica of Stonehenge he built as a World War I memorial. Today, the region is better known for the Mary Hill Museum of Art, Hill's former mansion that houses an eclectic collection in splendid isolation above the river. The plateau's harsh climate and constant winds make tree growth difficult. Most vegetation consists of sagebrush and native grasses adapted to the semi-arid conditions. The few trees that do survive tend to be stunted and wind-shaped, their growth rings telling stories of drought and fierce winter storms. This makes the presence of the Douglas Fir Grove, located half a mile northeast of the museum, all the more remarkable. The grove consists of 17 mature Douglas firs arranged in a rough semicircle, their trunks measuring between 3 and 4 feet in diameter. The trees provide the only significant shade for miles in any direction, creating a pocket of cooler, moister microclimate that supports understory plants typically found in wetter regions of the Pacific Northwest. Early photographs of the Mary Hill area from the 1920s show no trees at this location, only the typical shrub-steppe vegetation of the Columbia Plateau. The trees first attracted scientific attention in 1986 when botanist Dr. W.W.W. Dog Rebecca Walsh was conducting a survey of non-native vegetation in the Columbia Gorge for the Washington State Department of Ecology. Walsh had been documenting plant species that had been introduced to the region through human activity: ornamental trees around abandoned homesteads, escaped garden plants, and agricultural crops that had naturalized in the wild. The Mary Hill Grove caught her attention because Douglas firs rarely establish themselves naturally in such arid conditions, and these specimens appeared too large and mature to have been planted by recent human activity. The trees looked like they'd been growing there for at least a century, Walsh noted in her field journal, but there was no record of any tree planting projects in the area, and the local climate shouldn't support Douglas firs of this size. They were clearly thriving, but they shouldn't have been there at all. Walsh's initial survey revealed something that would puzzle her for months. Many of the trees bore carved initials, dates, and brief messages that appeared to span more than a century of human activity. The earliest carving she could identify was dated 1847, inscribed in bark that had long since healed over, leaving the numbers embedded deep in the trunk. The most recent carving was dated 1985, just 1 year before her visit. The scope and detail of the carvings was extraordinary. Walsh documented over 200 separate inscriptions, including initials, full names, dates, and brief messages like "heading west" and "safe crossing here." Some carvings referenced historical events. Oregon Territory established appeared with the date 1848, and railroad coming through was carved alongside 1883. It was like reading a chronological record of everyone who had passed through this area, Walsh wrote. Travelers on the Oregon Trail, railroad workers, early settlers, modern visitors, all had left their mark on these trees. But the earliest carvings suggested the trees had been here since the 1840s, which contradicted everything I knew about the region's settlement history and forest development. Walsh contacted the Klickitat County Historical Society to research the area's history and determine whether the grove might have been planted as part of some forgotten settlement or memorial project. Historical records showed that the Maryhill area was largely uninhabited until Sam Hill's arrival in 1907, with only occasional use by travelers following the Columbia River route between the Dalles and what would become Goldendale. County historian Margaret Chen reviewed Walsh's photographs of the tree carvings and identified several names and dates that corresponded to documented historical figures. J. Morrison, 1,851 matched records of James Morrison, a wagon master who led 5 Oregon Trail expeditions between 1850 and 1854. Sarah and Thomas Chen, 1,863, corresponded to her own great-great-grandparents, who had homesteaded near the Dalles and were known to have traveled the river route frequently. These aren't random names and dates, Chen told Walsh during a recorded interview in 1987. They match real people who lived in this area during the periods indicated. But that would mean the trees were here and mature enough to carve during the 1840s and 50s, which doesn't make sense given what we know about local vegetation. Dr. Michael Santos, a dendrochronologist from Oregon State University, visited the Maryhill Grove in August 1987 to conduct core sampling and tree ring analysis. Santos's expertise in dating Pacific Northwest forests made him the logical choice for determining the actual age of the Douglas firs and resolving the discrepancy between their apparent age and the historical record. Santos extracted core samples from 12 of the 17 trees, using an increment borer that removed pencil-thin sections of wood from the trunk to the center. Tree ring analysis would provide precise age determination by counting the annual growth rings and correlating them with known climate patterns. The results were impossible to reconcile with the carved evidence. Every core sample showed the same pattern, approximately 60 years of growth rings, indicating the trees had begun growing around 1927. There were no growth rings corresponding to the 1840s or 50s when the earliest carvings purported to have been made. The tree ring data is unambiguous, Santos reported in his preliminary findings. These Douglas firs began growing in the late 1920s. They're mature trees, but they're not old-growth specimens. They couldn't have been large enough to carve in 1847 because they didn't exist then. But the carvings showed clear evidence of age and authenticity. The bark had healed around the oldest inscriptions in patterns that would take decades to develop. The knife marks showed weathering consistent with long exposure to the elements. Chemical analysis of the carved areas indicated that the inscriptions had been made at different times over many decades, exactly as their dates suggested. Dr. Sarah Williams, a forensic botanist from the University of Washington, examined the relationship between the tree growth and the carved inscriptions in September 1987. Williams specializes in determining when damage to trees occurred, using growth patterns and healing responses to establish timelines for human interaction with forest environments. The healing patterns around the oldest carvings indicate they were made when the trees were already mature, Williams noted in her analysis. The bark formation and callus tissue development suggest some of these inscriptions are at least 80 to 90 years old, but the core samples show the trees themselves are only 60 years old. This creates a biological impossibility. Williams documented another disturbing aspect of the carvings. Several inscriptions appeared to reference future events with accurate dates. A carving reading, "Museum opens 1940, appeared on a tree in a location that would have been clearly visible from Sam Hill's mansion, though the Maryhill Museum didn't open until 1940, and Hill died in 1931. Another inscription, Highway Bridge 1962, accurately predicted the construction of the Sam Hill Memorial Bridge, which wasn't built until 1962. Local residents had been avoiding the grove for decades, though few were willing to discuss their reasons openly. Tom Bradley, whose family had operated a gas station along Highway 14, since the 1950s, provided one of the few recorded explanations. "My grandfather told me never to camp near those trees," Bradley said in a 1988 interview with Walsh. He said they remembered things that hadn't happened yet, and people who spent too much time there started feeling like they were living in the wrong century. "I thought it was just old-timer nonsense until I went up there myself in the 70s. Bradley described feeling disoriented during his visit to the grove, as if time was moving at different rates in different parts of the semicircle formed by the trees. "I'd look at a carving from the 1800s, and for a second, I could almost see the person who made it, like they were still standing there. It wasn't scary exactly, but it was wrong, like the trees were keeping records of things that happened in places they'd never been." The Washington State Department of Ecology classified Walsh's findings as anomalous vegetation data and suspended her research permit for the Maryhill area, pending further review. Her requests to expand the study were denied, and her preliminary report was reclassified as internal documentation, not subject to public disclosure. Santos attempted to publish his dendrochronological findings in the Journal of Forest Research, but the paper was rejected by peer reviewers, who noted insufficient explanation for the discrepancy between physical evidence and dating methodology. His raw data was archived by Oregon State University and remains available only to qualified researchers. Dr. Williams submitted her forensic botanical analysis to the Federal Bureau of Investigation, thinking the anachronistic carvings might indicate some form of historical fraud or forgery. The FBI declined to investigate, noting that no federal laws appeared to have been violated. In 1992, the Maryhill Grove was quietly transferred from state to federal ownership as part of a land consolidation project related to the Columbia River Gorge National Scenic Area. Public access to the trees was restricted, officially due to concerns about erosion and damage to sensitive vegetation. Signs posted around the grove warn visitors to stay on designated trails and prohibit camping or overnight stays in the area. Modern visitors to the Maryhill Museum occasionally ask about the grove of trees, visible from the museum's sculpture garden. But staff members are instructed to direct questions to the National Forest Service, which refers inquiries to the Columbia River Gorge Commission. No agency maintains official records of the carvings or their historical significance. The Douglas firs continue to grow, adding new rings each year in patterns that dendrochronologists can read like pages in a book. But the book they tell is only 60 years long, while the stories carved into their bark span 140 years of human passage through a landscape that shouldn't have supported their growth. The trees stand as witnesses to events they never lived through, keeping careful records of travelers who passed through forests that didn't exist in years when the ground beneath them held only sagebrush and wind. Some properties exist only in the spaces between what can be mapped. The Stillaguamish River Valley cuts through the western foothills of the Cascade Mountains, draining snowmelt and rainfall from peaks that rise over 6,000 feet above sea level. The valley encompasses both fertile farmland and dense second-growth forest, connected by a network of county roads that follow the river's meandering course toward Puget Sound. Snohomish County has maintained property records for the region since Washington achieved statehood in 1889, creating an archive of deeds, surveys, and tax assessments that document more than a century of land ownership and development. The Stillaguamish Valley was originally inhabited by the Stillaguamish tribe, whose villages dotted the riverbanks for thousands of years before European settlement. The first white homesteaders arrived in the 1860s, drawn by fertile soil and abundant timber. Logging operations dominated the valley's economy through the early 20th century, leaving behind a patchwork of clear-cuts, second-growth forests, and small communities that served the timber industry. County records reflect this history of settlement and development, with property boundaries established through federal land grants, homestead claims, and timber sales that carved the valley into a complex mosaic of private and public ownership. The Snohomish County Assessor's Office maintains detailed maps showing every parcel, road, and natural landmark, updated regularly to reflect changes in ownership and land use. The discovery that would challenge this carefully maintained record system began with a routine computer database conversion project in 1991. Patricia Rodriguez, a data entry clerk with the Snohomish County Assessor's Office, was tasked with converting paper property records into a new digital database system. The project involved scanning thousands of historical documents and entering property descriptions, ownership information, and tax assessment data into standardized computer files. Rodriguez had worked with county records for 8 years and was familiar with the typical variations in legal descriptions and surveying terminology used over decades of record keeping. On March 14, 1991, Rodriguez encountered a batch of property deeds that didn't match any locations she recognized from county maps. The deeds described parcels in the Stillaguamish Valley using standard legal terminology, township, range, and section numbers that should have corresponded to specific geographic coordinates. But when Rodriguez attempted to verify the locations against county survey maps, the described properties didn't exist. "I thought I was making data entry errors," Rodriguez later told investigators from the Washington State Auditor's Office. The legal descriptions looked legitimate, but they referenced roads and landmarks I'd never heard of, and I'd been working with Stillaguamish Valley records for years. When I checked the survey maps, there was nothing at the coordinates the deeds described. Rodriguez's supervisor, County Assessor Margaret Chen, initially attributed the discrepancies to transcription errors or misfiled documents from other counties. But a detailed review revealed that all 847 problematic deeds shared several unusual characteristics. They were dated between 1943 and 1955. They referenced the same network of roads and landmarks that appeared on no county maps, and they were all notarized by Harold Morrison, whose stamp and signature appeared on every document. Chen researched Morrison's credentials and discovered that he had been a licensed notary public in Snohomish County from 1938 until his death in a car accident on Highway 2 in November 1956. Morrison's notarial records, maintained by the Washington Secretary of State, showed routine activity through 1955, but made no reference to the extensive property documentation found in the county files. The legal descriptions in Morrison's deeds followed standard surveying conventions, but described a geography that didn't match the actual Stillaguamish Valley. Properties were referenced as being north of Cascade Creek Road and adjacent to the Miller homestead, but no Cascade Creek Road appeared on any county or state highway maps, and no Miller family had homesteaded in the Stillaguamish Valley according to historical records. Dr. James Mitchell, a cartographer from the University of Washington, was contracted by the county to analyze the geographic references in the mysterious deeds. Mitchell's expertise in historical surveying methods and land records made him the logical choice for determining whether the properties might represent legitimate but unmapped locations. The legal descriptions are technically precise and follow established surveying protocols, Mitchell noted in his preliminary report. They reference a complete infrastructure of roads, creeks, and landmarks that would be necessary to support 847 separate properties. But this entire geographic framework appears to exist only in the deeds themselves. Mitchell's analysis revealed that the described properties would occupy approximately 32 square miles of territory that, according to all available maps, consisted primarily of national forest land and privately owned timber holdings. The deeds described residential lots, commercial properties, and agricultural parcels in areas that satellite imagery showed as dense forest, with no evidence of development or human habitation. Tom Bradley, a surveyor who had worked in the Stillaguamish Valley since 1968, reviewed selected deeds at the county's request. Bradley was familiar with every major road, creek, and landmark in the region. Having conducted boundary surveys for dozens of property owners over 2 decades, I've walked every square mile of that valley, Bradley told Chen during a recorded interview in April 1991. The roads and creeks described in those deeds don't exist. Cascade Creek Road, Miller's Bridge, the North Fork Settlement, none of these places are real. But the surveying terminology is perfect, like someone who knew exactly how to write a proper legal description, but was describing a completely different valley. More disturbing was what Chen discovered when she researched the tax payment history for the 847 properties, despite referencing non-existent locations. Every parcel had property taxes assessed annually since 1956, the year after Morrison's death. And those taxes were paid promptly each year by money orders sent from a post office box in Everett. The post office box, numbered 4739, was registered under the name Stillaguamish Valley Development Company, with no associated street address or telephone number. Postal records showed that the box had been rented continuously since 1956, with rental fees paid annually in cash. The Everett postmaster confirmed that tax payments for hundreds of Snohomish County properties arrived at the box each year, but no individual had ever been observed collecting mail from the address. Sarah Williams, an investigator with the Washington State Auditor's Office, attempted to trace the ownership of the phantom properties through chain of title research. Williams specialized in investigating property tax fraud and had extensive experience with complex ownership structures designed to conceal true property ownership. The paper trail is meticulous, Williams reported after 6 months of investigation. Every deed has proper notarization, legal descriptions that follow surveying standards, and a clear chain of ownership. The problem is that the entire chain refers to properties that don't exist on Earth. It's as if someone created a parallel property system for an alternate version of the Stillaguamish Valley. Williams discovered that the original property owners named in Morrison's deeds had been real people who lived in Snohomish County during the 1940s and 50s. Death certificates and family records confirm their identities and approximate dates of residence. But none of these individuals appeared in any other property records, and their descendants had no knowledge of land ownership in the Stillaguamish Valley. The Internal Revenue Service conducted its own investigation after Williams reported the tax payment irregularities. IRS. Auditors traced the money orders used for property tax payments to a bank account that had been closed since 1962, yet somehow continued to fund the annual tax payments. Bank records showed no deposit activity since the account closure, but withdrawals for exact tax amounts continued to clear each year. Federal investigators attempted to place surveillance on Post Office Box 4739, but their efforts were complicated by the fact that the box appeared to service itself. Postal workers reported that tax payment envelopes addressed to Snohomish County arrived at the box each year around the December 15th deadline, but security cameras never recorded anyone depositing mail. In 1992, the Snohomish County Council voted to remove the 847 phantom properties from active tax rolls, citing the impossibility of collecting taxes on non-existent land. But the decision was overturned by the Washington State Department of Revenue, which noted that the properties had tax payment histories dating back 36 years and showed no evidence of delinquency or fraud. The State Attorney General's office opened an investigation into potential property fraud in 1993, but closed the case after determining that no financial crimes had been committed. The phantom properties generated legitimate tax revenue for the county. Their legal descriptions followed proper formatting, and all tax obligations were met punctually each year. Chen was transferred to a different county department in 1994, and her replacement was instructed to treat the 847 properties as special assessment parcels, requiring no active management or investigation. Rodriguez left county employment and moved to Eastern Washington, declining to discuss her experiences with the Stillaguamish papers. Dr. Mitchell's cartographic analysis was never completed. His research files were transferred to university archives in 1995 and classified as restricted access pending academic review. Freedom of Information Act requests for county records related to the Gloated of Go review. Phantom properties have been denied under exemptions for ongoing legal proceedings and confidential tax information. Today, property tax statements for 847 parcels of non-existent Stillaguamish Valley real estate continue to arrive at Post Office Box 4739 each December. The taxes are paid promptly by money orders that originate from a closed bank account, funding county services for residents who live on roads that exist only in the careful handwriting of a notary public who died in 1956. The Stillaguamish River continues to flow through a valley that county records insist contains nearly 1,000 more properties than can be found on any map, creating a parallel geography where property lines are drawn through forests that remember a different version of their own settlement. And tax assessments are calculated for communities that exist only in the spaces between what surveyors have measured and what documents have recorded. Some waters refuse to acknowledge the seasons. Lake Chelan extends 55 miles through the North Cascade Mountains, carved by glacial action into a narrow, fjord-like basin that reaches depths of over 1,400 feet. The lake sits at an elevation of 1,098 feet above sea level, surrounded by peaks that rise to over 8,000 feet and receive heavy snowfall from October through April. During winter months, air temperatures in the Chelan Valley frequently drop below 0 degrees Fahrenheit, and the lake's surface often develops a thin layer of ice along the protected shoreline areas. The lake serves as the primary water source for the town of Chelan and surrounding agricultural areas, supporting a year-round population of 4,000 residents and seasonal tourism that swells to over 20,000 visitors during summer months. The Washington State Department of Fish and Wildlife maintains detailed water temperature records for Lake Chelan, monitoring conditions that affect native fish populations and recreational activities. These records show typical seasonal variations, surface temperatures ranging from 35 degrees in winter to 75 degrees during summer peak, with deeper waters maintaining relatively stable temperatures around 45 degrees year-round. The lake's extreme depth and glacial origins create unique thermal characteristics. Cold water from mountain streams enters at the north end, while warmer surface water concentrates near the south shore where the town of Chelan has developed. Wind patterns and underwater topography create predictable circulation patterns that marine biologists have studied for decades, establishing Lake Chelan as a model alpine lake ecosystem. The first documented observation of what would become known as the thermal anomaly occurred on February 11, 1983, during routine winter water quality monitoring conducted by the Washington State Department of Ecology. Marine biologist Dr. Sarah Martinez was collecting water samples from various depths and locations around the lake to assess winter conditions for the department's annual water quality report. The work required measuring temperature, dissolved oxygen levels, and pH at standardized locations that had been monitored for over 20 years. Martinez used precision instruments calibrated to scientific standards, following protocols established for consistent data collection across multiple seasons and years. At approximately 10:30 that morning, Martinez recorded a water temperature of 68.2 degrees Fahrenheit at a location 200 feet from the north shore, in an area where the lake depth measured approximately 300 feet. The reading was so far outside expected parameters that Martinez initially assumed equipment malfunction and repeated the measurement using backup instruments. "I thought my thermometer was broken," Martinez wrote in her field notes. Air temperature was 12 degrees below zero. The lake had surface ice, and I was getting a summer reading from water that should have been barely above freezing. I used 3 different instruments and got the same result every time. Martinez marked the location with GPS coordinates and took additional measurements in a grid pattern around the anomalous reading. Water temperature returned to expected winter levels at distances greater than 50 feet from the central point, creating a sharply defined circular zone of warm water approximately 100 feet in diameter. The temperature gradient between the warm zone and surrounding water was so abrupt that Martinez could detect the boundary by moving her instruments just a few feet in any direction. The discovery prompted an expanded investigation by the Washington State Department of Fish and Wildlife, which sent a team of aquatic biologists to Lake Chelan in March 1983 to verify Martinez's findings and determine possible causes for the thermal anomaly. Dr. Robert Chen, the department's senior fish habitat specialist, led the investigation team using more sophisticated temperature monitoring equipment designed to detect underwater thermal variations. Chen had 25 years of experience studying Washington's mountain lake ecosystems and was familiar with the range of natural phenomena that could affect water temperature. We deployed multiple temperature sensors in a precise grid pattern around Dr. Martinez's coordinates, Chen reported in his preliminary findings. The warm water zone was perfectly circular, with water temperature dropping from 68 degrees at the center to 41 degrees at the perimeter, over a distance of exactly 50 feet. The gradient was linear and consistent, suggesting a point heat source directly beneath the center of the circle. Chen's team used underwater cameras and sonar equipment to examine the lake bottom beneath the thermal anomaly, searching for geological features that might explain the temperature difference. The lake floor in that area consisted of typical glacial sediment, silt, clay, and occasional rock debris, with no visible thermal vents, hot springs, or other obvious heat sources. More puzzling was the biological response to the warm water zone. Fish populations in Lake Chelan included native trout species that typically sought warmer water during winter months, but underwater cameras revealed that fish actively avoided the heated area. Schools of lake trout and kokanee salmon would approach the thermal boundary and then abruptly change direction, as if encountering an invisible barrier. The fish behavior was unlike anything I'd observed in 30 years of fieldwork, Chen noted. These species should have been attracted to the warm water, especially during winter, when metabolic benefits would be significant. Instead, they acted like the area was contaminated or dangerous, even though our water quality tests showed no chemical abnormalities. Local fishing guides had been noticing unusual patterns around the North Shore for several years before the scientific documentation began. Tom Bradley, who operated guided fishing tours on Lake Chelan from 1975 through 1998, described consistent fishing dead zones that seemed to move slightly but remained generally in the same area. There was always this spot where fish just wouldn't bite, Bradley told Chen's investigation team. Didn't matter what season, what bait, what technique, nothing worked in that one area. I started marking it on my maps as the dead circle and would steer clients away from it. Fish would be hitting all around the edges, but the center was always empty. Bradley's fishing logs, maintained for insurance and guide license requirements, showed a consistent pattern of avoided areas that corresponded closely to Chen's thermal measurements. The logs indicated that the fishing dead zone had been noticeable since at least 1979, 4 years before scientific documentation of the temperature anomaly began. Dr. Jennifer Walsh, a geologist from Central Washington University, was brought in to assess possible geological explanations for the thermal anomaly. Walsh specialized in geothermal activity and had experience investigating unusual heat sources in Washington's Cascade region. Her analysis focused on subsurface geology and the possibility of deep thermal vents or mineral springs. Geothermal heating typically shows irregular patterns related to rock formations and underground water flow, Walsh explained in her report. This thermal anomaly is geometrically perfect, a precise circle with linear temperature gradients that suggest an artificial rather than natural heat source. No known geological process creates this kind of regular, sustained thermal pattern. Walsh's subsurface mapping revealed that the lake bottom beneath the thermal anomaly was underlain by solid granite bedrock at a depth of approximately 40 feet below the sediment layer. Core samples showed no evidence of geothermal activity, mineral deposits, or underground water circulation that could account for the sustained heat generation. In August 1983, recreational divers from the Wenatchee Scuba Club reported unusual sensory experiences while diving in the thermal zone. Club president Mike Santos, a certified dive instructor with over 15 years of experience in Pacific Northwest waters, led several exploration dives to investigate the underwater characteristics of the warm water area. The water temperature was like a heated swimming pool, even at depth, Santos reported to the Fish and Wildlife Investigation Team. But there was something unsettling about diving there. Several of our members reported feeling like they were being watched from below, even though visibility was good and we could see the lake bottom clearly. The sensation was strong enough that 2 divers ended their dives early. Santos described the diving experience as psychologically disturbing, despite the absence of any visible threats or unusual underwater features. It felt like diving over something that was paying attention to us, he said. Not dangerous exactly, but aware. Like swimming over a sleeping giant that might wake up if we stayed too long. The Washington State Department of Fish and Wildlife classified the Lake Chelan thermal anomaly as an ongoing research project in 1984 and restricted public diving in the affected area, pending further investigation. The restriction was officially based on potential underwater hazards and protection of sensitive fish habitat. But internal documents obtained through public records requests cited concerns about unexplained diver distress reports. Dr. Martinez's request to expand the thermal monitoring program was approved for the 1985 field season, but funding was withdrawn after budget cuts eliminated several research positions within the Department of Ecology. Martinez was transferred to a different project, and responsibility for Lake Chelan monitoring was assigned to staff members with no background in thermal anomaly research. The thermal zone continued to maintain its perfect 68-degree temperature through subsequent seasons, remaining constant during both winter freezes and summer heat waves. Temperature monitoring conducted by various agencies between 1985 and 1992 confirmed the persistent nature of the anomaly, but no comprehensive study was undertaken to determine its cause or mechanism. In 1993, the Lake Chelan thermal monitoring program was quietly discontinued as part of statewide budget reductions affecting environmental research. Official water quality monitoring continued at other locations around the lake, but the anomalous thermal zone was removed from routine sampling schedules. Dr. Chen's biological research files were transferred to state archives in 1994 and classified as inactive research data with restricted public access. Walsh's geological analysis remained unpublished after peer reviewers noted insufficient data to support conclusions regarding anomalous geothermal activity. Santos continued diving in Lake Chelan through the 1990s, but avoided the thermal zone after several club members reported persistent anxiety following dives in the area. There's something down there that doesn't want to be disturbed, he told local newspaper reporters in 1996. The warm water is just the surface effect of whatever's causing the real phenomenon. Today, Lake Chelan attracts thousands of recreational visitors annually for boating, fishing, and swimming. Commercial fishing guides continue to avoid a roughly circular area approximately 200 feet from the north shore, though most attribute the avoidance to poor fishing conditions rather than thermal anomalies. Water temperature monitoring is conducted by automated sensors that record average conditions for the entire lake, without the spatial resolution necessary to detect localized thermal variations. The warm water zone persists with mechanical regularity, maintaining its perfect circle and constant temperature regardless of seasonal changes that affect the rest of the lake. Fish continue to avoid the area with behaviors that suggest instinctive recognition of something their biology tells them to fear. while the water above remains warm and inviting to any swimmer, unaware that they're floating over something that generates heat without fire, creates perfect circles without geometry, and watches from depths that instruments can measure but never fully explain. Some roads measure distance differently than maps suggest. U.S. Highway 101 encircles Washington's Olympic Peninsula in a loop that covers approximately 360 miles of coastal and forest terrain. The highway was completed in 1931, connecting remote logging communities and coastal towns through some of the most challenging geography in the Pacific Northwest. The route passes through Olympic National Forest and skirts the boundaries of Olympic National Park, following river valleys and coastal plains where earlier roads had failed due to washouts, landslides, and the region's notoriously wet climate. The Olympic Peninsula remained largely isolated until Highway 101 provided reliable, year-round transportation. Before the highway's completion, many communities could only be reached by boat or seasonal logging roads that became impassable during winter storms. The Washington State Highway Department faced significant engineering challenges in building the route, including unstable soils, frequent flooding, and terrain that required numerous bridges and retaining walls to maintain a passable roadway. Mile markers along Highway 101 were installed according to standard Department of Transportation protocols, with markers placed at 1-mile intervals and numbered consecutively from south to north along the western section of the Peninsula Loop. The markers serve as reference points for emergency services, maintenance crews, and travelers, providing precise location data that corresponds to official highway maps and GPS coordinates. The system worked without incident for over 50 years, until maintenance crews discovered an anomaly that would challenge basic assumptions about linear measurement and geographic consistency. On September 14, 1985, Washington State Department of Transportation Maintenance Supervisor Patricia Rodriguez was conducting routine inspection of mile markers between Forks and the Quinault River. The work involved verifying that markers were properly positioned, readable, and corresponded to official distance measurements maintained by the department's surveying division. Rodriguez had performed similar inspections throughout western Washington for 12 years and was familiar with the standard procedures for identifying and correcting marker placement errors. At approximately 2:15 in the afternoon, Rodriguez encountered mile marker 73 along the northbound lane of Highway 101, approximately 18 miles south of Forks. She recorded the marker's position using GPS coordinates and noted its condition in her inspection log. Continuing north, Rodriguez expected to find mile marker 74 at the next mile interval, but instead discovered another mile marker, 73, exactly 2.7 miles from the location of the first marker. "I thought someone had stolen marker 74 and replaced it with a duplicate 73, Rodriguez later reported to her supervisor, Regional Maintenance Chief David Kim. But both markers showed normal weathering patterns and appeared to have been in place for years. The installation posts were properly set, and there was no evidence of recent disturbance around either marker. Rodriguez used a surveyor's wheel to measure the distance between the 2-mile marker 73 locations, confirming that they were separated by exactly 2.7 miles of highway. She then continued her inspection route and found mile marker 74 at the expected location north of the second marker 73, suggesting that the highway's mile markers continued in proper sequence despite the duplication. Kim reviewed Rodriguez's inspection report and initially attributed the anomaly to a clerical error during marker installation or replacement. The Department of Transportation maintained detailed records of all highway markers, including installation dates, maintenance history, and any replacements due to damage or theft. But research into the mile marker 73 records revealed no history of replacement, duplication, or installation errors. The original highway construction records from 1931 showed mile marker 73 installed at a single location that corresponded to the first marker Rodriguez had documented. No records indicated installation of a second marker bearing the same number. Department surveying maps showed Highway 101 as a continuous route with sequential mile markers, making no reference to duplicate numbering. Dr. James Mitchell, a cartographer from the University of Washington, was contracted by the Washington State Department of Transportation to analyze the mile marker discrepancy and determine whether it represented a surveying error or administrative oversight. Mitchell's expertise in highway mapping and GPS technology made him qualified to resolve what appeared to be a straightforward measurement problem. The GPS coordinates for both mile marker 73 locations are accurate and properly positioned relative to the highway route, Mitchell reported after conducting field surveys in October 1985. The markers are exactly 2.7 miles apart, and both appear to be legitimate Department of Transportation installations. But the highway maps show only 1 mile marker, 73, and the total distance calculations don't account for the additional 2.7 miles of roadway. Mitchell's analysis revealed that the section of Highway 101 between the 2 mile marker 73 locations measured 2.7 miles when driven in either direction, but official highway maps calculated the distance as 0, treating both markers as occupying the same position on the route. This created a discrepancy where the physical highway was 2.7 miles longer than cartographic records indicated. Local residents and frequent travelers of Highway 101 began reporting unusual experiences related to the duplicate mile markers after the Department of Transportation's investigation became known through local newspapers. Sarah Williams, a nurse who commuted daily between Forks and Quinault, noticed that her usual travel time increased by approximately 4 minutes when driving past both 73 markers. "I'd been making the same drive for 8 years and knew exactly how long it took," Williams told investigators in November 1985. "After they discovered the duplicate markers, I started timing my trips more carefully and realized I was consistently arriving 4 minutes later than expected. But my odometer showed I was driving the same distance as always." Williams described the extra 4 minutes as feeling stretched out, like the highway was taking longer to traverse without covering additional distance. "It wasn't heavy traffic or slower driving," she explained. "The road just seemed to take more time to complete, like the minutes themselves were longer in that section." Tom Bradley, a logging truck driver who had used Highway 101 since the 1970s, reported similar temporal distortions when hauling loads past the duplicate mile markers. Bradley's delivery schedules were precisely timed due to mill operations and union regulations, making him acutely aware of travel time variations. Between those 273 markers, time moved differently, Bradley said in a recorded interview with Department of Transportation investigators. "Not slower exactly, but denser. Like each mile took more time to happen, even though the speedometer showed normal speed and the distance was the same. My GPS started giving me arrival times that were consistently off by several minutes." More disturbing were reports from travelers who used GPS navigation devices while driving past the duplicate mile markers. Several motorists reported that their GPS units calculated impossible travel times, showing that they had covered the 2.7 miles between markers in negative time, or had somehow arrived at their destination before departing. Margaret Chen, a regional sales representative who drove Highway 101 monthly, documented GPS anomalies in her travel logs throughout 1986 and 1987. "My GPS would show normal progress until I reached the first marker 73, Chen noted. Then it would start calculating impossible arrival times, sometimes showing that I'd already reached destinations that were still miles ahead. The readings would correct themselves after I passed the second marker 73. The Washington State Department of Transportation commissioned a comprehensive survey of the entire Highway 101 route in 1987, using professional surveying equipment to verify all mile marker positions and resolve the duplication issue. The survey team, led by licensed surveyor Robert Santos, used electronic distance measurement tools and GPS coordinates to create precise maps of the highway route. Santos's survey confirmed that two distinct mile markers bearing the number 73 were properly positioned along Highway 101, separated by exactly 2.7 miles of paved highway. Both markers were legitimate Department of Transportation installations, showing proper mounting hardware and materials consistent with standard highway marking procedures used since the 1970s. From a surveying perspective, there's nothing abnormal about the markers themselves, Santos reported. They're correctly positioned, properly installed, and accurately numbered. The problem is that having two markers with the same number violates fundamental principles of sequential numbering systems. It's like having two different houses with the same address on the same street. Santos's attempts to resolve the duplication by renumbering one of the markers were complicated by Department of Transportation regulations, requiring mile markers to correspond to actual measured distances from designated starting points. Renumbering either marker would create inconsistencies with official highway maps and GPS databases that relied on sequential mile marker numbering. The Federal Highway Administration reviewed the Washington State Department of Transportation survey data in 1988 and concluded that the duplicate mile markers represented a unique administrative circumstance that did not violate federal highway standards as long as both markers were properly maintained and clearly visible to travelers. The FHA recommended that Washington State develop internal protocols for managing duplicate mile marker references, but took no action to require correction of the numbering system. The decision effectively legitimized the existence of two mile marker 73 locations on Highway 101. Department of Transportation officials attempted to address the GPS timing anomalies reported by travelers by coordinating with manufacturers of navigation devices. But GPS manufacturers noted that their systems calculated travel times based on distance and speed measurements that showed no abnormalities in the Highway 101 corridor. The GPS devices are functioning correctly, explained technical specialist Jennifer Walsh from a major navigation system manufacturer. They're measuring actual distance traveled and calculating arrival times based on observed speeds. If travelers are experiencing temporal distortions, the problem isn't with the GPS technology, it's with time itself behaving differently in that section of highway. In 1989, the Department of Transportation installed additional signage near both mile marker 73 locations, warning travelers that mile marker numbering anomalies may affect GPS navigation, and advising drivers to rely on visual landmarks rather than electronic navigation in the area. The signs remain in place today, though their cryptic wording has generated more confusion than clarification among travelers. Rodriguez, the maintenance supervisor who first documented the duplicate markers, was transferred to a different highway district in 1990 and took early retirement 2 years later. Her inspection records from the Highway 101 route were archived and classified as administrative reference documents, not available for public review. Today, both mile marker 73 locations continue to mark their respective positions along Highway 101, separated by exactly 2.7 miles of highway that appears on no official distance calculations. GPS devices still calculate impossible travel times for drivers who traverse the section between markers, though most travelers attribute the anomalies to technical glitches rather than temporal distortions. The Olympic Peninsula Loop continues to carry thousands of travelers annually past two markers that share the same number but measure different positions in space, creating a section of highway where distance and time refuse to maintain their usual relationship, and where the road itself seems to remember that some measurements are more persistent than the mathematics that created them. Some winds blow against the direction of all others. Arlington Municipal Airport sits on a plateau above the Stillaguamish River Valley in Snohomish County, Washington, 35 miles northeast of Seattle. The airport was constructed in 1942 as a training facility for civilian pilots during World War II, built on land that had previously been logged and cleared for agriculture. The runway stretched 2,400 feet across relatively flat terrain, with hangars and support buildings arranged around a central terminal that served both military training operations and civilian aviation until the end of the war. After 1945, Arlington Municipal became a regional airport serving private aircraft, flight training schools, and occasional commercial cargo operations. The facility remained active through the 1970s, supporting a community of pilots and aviation businesses that provided services throughout the Puget Sound region. Weather monitoring equipment installed in 1953 included standard instruments for measuring wind speed, direction, and atmospheric pressure data essential for safe aircraft operations in an area known for rapidly changing weather conditions. The Cascade Mountains create complex wind patterns throughout western Washington, with air currents that can shift dramatically based on elevation, topography, and seasonal weather systems. Arlington's location at the edge of the Cascade foothills made accurate wind measurement critical for pilots navigating the transition between mountain and lowland weather conditions. The airport's windsock, mounted on a standard pole near the runway approach, provided visual wind direction information that pilots used for takeoff and landing decisions. Arlington Municipal Airport ceased operations on October 15, 1987, when declining usage and maintenance costs made continued operation economically unfeasible. The closure followed a pattern common to small regional airports during the 1980s, as changes in aviation regulations and insurance costs forced many facilities to shut down. The runway was officially deactivated, buildings were secured, and most equipment was removed or transferred to other airports. But several items remained in place, including the windsock that had served pilots for over 30 years. Airport manager David Santos conducted the final inspection of the facility on October 20, 1987, documenting the condition of infrastructure that would remain under county ownership, pending potential future use. Santos noted that the windsock appeared to be in good condition, with the fabric cone responding normally to wind direction. His report included routine observations about facility security and weather monitoring equipment that would be discontinued with the airport's closure. 3 weeks later, Santos returned to Arlington Municipal to investigate reports from neighbors that aircraft were still using the closed runway. Local residents had reported seeing the windsock and assumed the airport remained operational despite official closure notices. Santos found no evidence of unauthorized aircraft activity, but noticed something that would puzzle him for years. The windsock was pointing northwest, despite winds that were clearly blowing from the south. "I thought the windsock mechanism was broken," Santos reported to the Snohomish County Facilities Management Office. "But the fabric was moving normally, responding to air movement just like it should. The problem was that it was pointing in the opposite direction from the actual wind. I could feel the south wind on my face, but the windsock was indicating northwest wind." Santos tested the windsock mounting system and found no mechanical problems. The pole was properly secured, the swivel mechanism operated freely, and the fabric cone showed no tears or damage that would affect its response to air movement. Yet the windsock continued to indicate northwest wind direction while surrounding vegetation clearly responded to southerly breezes. The anomaly persisted through the winter of 1987 and into 1988, attracting attention from local pilots, who continued to monitor weather conditions at the closed airport out of professional habit. Tom Bradley, a flight instructor who had used Arlington Municipal for over 15 years, began documenting the windsock's behavior as part of his personal weather observations. "Every time I drove past the airport, that windsock was pointing northwest," Bradley noted in his pilot log. "Didn't matter what the weather was doing, storms from the south, easterly winds, calm conditions, the sock always pointed the same direction." It was like there was a permanent wind blowing only at that one spot. Bradley's documentation showed that the windsock maintained its northwest orientation through weather patterns that included storms from multiple directions, calm periods with no measurable wind, and seasonal changes that should have produced varying wind directions typical of the Pacific Northwest climate. Dr. Patricia Chen, a meteorologist from the University of Washington, investigated the Arlington windsock anomaly in June 1988 after receiving reports from the National Weather Service office in Seattle. Chen specialized in localized weather phenomena and had experience with microclimate effects created by topography and man-made structures. I set up instruments around the airport perimeter to measure wind speed and direction at multiple locations, Chen reported in her preliminary findings. The windsock was definitely responding to air movement, but the air movement was isolated to the immediate area around the windsock pole. 20 feet away, wind patterns were completely normal. Chen's measurements revealed that the anomalous wind pattern extended in a roughly circular area with a diameter of approximately 100 feet, centered on the windsock location. Within this zone, air moved consistently from southeast to northwest at speeds averaging 8 to 12 miles per hour, regardless of regional weather conditions. Outside the circle, wind patterns matched measurements from nearby weather stations and followed normal atmospheric behavior. It was like standing next to an invisible fan that was always running, Chen described during a recorded interview. Step into the circle and you could feel the northwest wind. Step out and you'd experience whatever the actual regional wind was doing. The boundary was surprisingly sharp. You could literally walk from one wind pattern to another. Margaret Williams, a pilot who had learned to fly at Arlington Municipal in the 1970s, visited the closed airport regularly to maintain her connection with the flying community. Williams noticed psychological effects associated with the persistent wind pattern that extended beyond simple meteorological curiosity. Standing near that windsock felt wrong, Williams said in a 1989 interview. Not dangerous exactly, but unnatural, like the air itself was stuck in the wrong direction, flowing against the rest of the world. Some of the old-timers said it made them feel like they were standing in the past, when the airport was still active and the wind patterns were normal. Local residents began avoiding the abandoned airport, particularly the area near the runway where the windsock continued its northwest vigil. Sarah Morrison, whose property bordered the airport's eastern boundary, described feeling disoriented. When working in her garden within sight of the windsock, I'd be working outside and glance over at that sock, and for a moment I'd forget which way the wind was supposed to be blowing, Morrison recalled. It was like looking at a compass needle that pointed in the wrong direction. Not broken, just consistently wrong in a way that made you question your own sense of direction. The Federal Aviation Administration conducted an inspection of the closed Arlington Municipal Airport in September 1988, prompted by reports that the windsock might be providing incorrect wind information to aircraft that might mistake the facility for an active airport. F.A. Inspector Robert Mitchell documented the windsock anomaly, but found no safety violations since the airport was officially closed to aircraft operations. The windsock is functioning normally within its localized wind environment, Mitchell noted in his report. The anomaly appears to be atmospheric rather than mechanical. Since the airport is closed and properly marked as such, the windsock poses no navigational hazard to aircraft operations. Mitchell's report was filed with FAA regional headquarters and classified as facility maintenance documentation, with no further investigation recommended. The FAA took no action to remove or repair the windsock, noting that it remained county property and posed no federal aviation concerns. Dr. Chen attempted to expand her meteorological study of the Arlington wind pattern in 1989, but was unable to obtain research funding from the National Science Foundation. Her grant application was rejected, with comments noting insufficient scientific significance and limited applicability to broader atmospheric research. The Washington State Department of Ecology briefly investigated the windsock anomaly in 1990 as part of a broader study of localized climate effects, but discontinued the investigation after determining that the phenomenon posed no environmental threats or regulatory concerns. Santos, who had first documented the wind pattern anomaly, left county employment in 1991 and moved to eastern Washington. His files on Arlington Municipal Airport were archived and transferred to the county assessor's office, where they remain classified as closed facility documentation with restricted public access. In 1995, vandals damaged several buildings at the abandoned Arlington Municipal Airport, but left the windsock untouched. County maintenance crews reported that the windsock continued to indicate northwest winds during their cleanup operations, despite working in actual southerly breezes that blew debris across the runway. Today, Arlington Municipal Airport remains closed and largely abandoned, with deteriorating buildings and a runway that serves no aircraft. The windsock stands as the facility's most persistent remnant, still pointing northwest with mechanical consistency regardless of weather conditions that change hourly around it. Pilots flying over the area occasionally report the visual anomaly to air traffic control, noting that the abandoned airport's windsock appears to indicate wind conditions that contradict their aircraft instruments. But the reports are filed as curiosities rather than hazards, since no aircraft are authorized to use the closed facility. The windsock continues its northwest vigil, marking direction in a column of air that flows against all surrounding wind patterns, maintaining the orientation of a breeze that began blowing on the day the airport closed, and has never acknowledged that its purpose ended with the last aircraft departure. In a landscape where wind patterns shift with weather and season, one small circle of air remains permanently committed to a direction that serves no flights and guides no landings, yet persists with the reliability of something that remembers when its measurements mattered. Some Earth remembers harvests that were never planted. The Palouse Hills stretch across southeastern Washington and northern Idaho, forming one of the most productive wheat-growing regions in the United States. The landscape consists of rolling hills covered in deep, fertile soil deposited by wind over thousands of years, creating a terrain uniquely suited to dryland farming. The region produces over 100 million bushels of wheat annually, with some fields maintaining continuous cultivation since homesteaders arrived in the 1870s. The Palouse soil formed from loess fine particles of rock and mineral carried by wind from glacial outwash plains and deposited in layers that can reach depths of over 200 feet. This geological process created soil conditions that retain moisture and nutrients with exceptional efficiency, supporting wheat varieties that thrive in the region's semi-arid climate. Agricultural researchers have studied Palouse soils extensively, documenting their composition and agricultural potential through decades of scientific analysis. Whitman County encompasses much of the Washington portion of the Palouse, with county seat Pullman serving as home to Washington State University's College of Agricultural, Human, and Natural Resource Sciences. The university has maintained agricultural research programs in the region since 1892, conducting soil studies that support farming practices throughout the Pacific Northwest. These research programs include detailed analysis of soil composition, crop rotation effects, and the long-term sustainability of intensive wheat production. The discovery that would challenge basic assumptions about agricultural history and soil science began with a routine soil survey conducted in March 1988. Dr. Margaret Rodriguez, a soil scientist with Washington State University's Agricultural Extension Program, was conducting a comprehensive analysis of Palouse soil composition as part of a long-term study tracking changes in soil chemistry over decades of farming. The research involved collecting samples from fields across Whitman County and analyzing them for nutrient content, organic matter, and trace elements that might indicate historical land use patterns. Rodriguez's methodology followed standard protocols established by the U.S. Department of Agriculture for soil analysis, using spectroscopic techniques to identify microscopic plant residues and chemical signatures that could provide information about previous crops grown in sampled locations. The analysis typically revealed expected results: traces of wheat varieties known to have been cultivated in the region, along with occasional evidence of barley, peas, and other crops documented in local agricultural records. On March 23, 1988, Rodriguez analyzed soil samples collected from a field owned by the Morrison family, located 12 miles southeast of Pullman. The Morrison farm had been in continuous wheat production since 1885, with detailed records of crop varieties and farming practices maintained by 4 generations of the family. The field selected for sampling represented typical Palouse agricultural conditions, with no unusual history of experimental crops or non-standard farming practices. The initial analysis showed normal results for a wheat field with over a century of cultivation, Rodriguez noted in her laboratory records. But when I conducted more detailed spectroscopic analysis, I found plant protein signatures that didn't match any wheat varieties known to have been grown in the Palouse region. Rodriguez identified trace amounts of plant material from what appeared to be wheat varieties with genetic markers not found in any cultivars documented in regional agricultural records. The protein signatures suggested wheat strains with characteristics that didn't match the historical progression of varieties grown in the Pacific Northwest, including some markers that appeared to represent more advanced genetic development than varieties available in 1988. Concerned that her results might indicate contamination or analytical error, Rodriguez repeated the analysis using samples from 6 additional fields across Whitman County. Each location showed similar anomalous results: trace amounts of crop residues that didn't correspond to documented agricultural history, mixed with expected signatures from known wheat varieties. Dr. James Chen, a plant geneticist from the University of Idaho, who specialized in wheat breeding and variety development, reviewed Rodriguez's findings at her request in April 1988. Chen's expertise in wheat genetics and familiarity with variety development timelines made him qualified to interpret the unusual protein signatures Rodriguez had documented. The genetic markers Dr. Rodriguez identified are consistent with wheat varieties that incorporate specific traits for drought resistance and pest tolerance, Chen reported in his preliminary analysis. But several of these traits weren't successfully incorporated into commercially available wheat until the early 1990s. Some markers suggest genetic modifications that are still experimental as of 1988. Chen's analysis revealed that some soil samples contained trace amounts of plant material with genetic characteristics that wouldn't be developed until years after the samples were collected. Most disturbing were protein signatures that matched wheat varieties that wouldn't be released for commercial production until 1994 and 1995, incorporating genetic traits that were still being researched in university laboratories. Tom Morrison, whose family had farmed the sampled land for over a century, provided detailed records of every crop variety planted on his property since his great-grandfather's initial homestead. The Morrison family maintained meticulous agricultural records, including seed sources, planting dates, and harvest yields that documented exactly which wheat varieties had been cultivated on each field. "We've never grown anything but standard wheat varieties available from regional seed companies," Morrison told Rodriguez during a recorded interview. "My family's records go back to the 1880s, and we've never participated in experimental crop programs or planted anything that wasn't commercially available. I have no idea how genetic material from future wheat varieties could be in our soil." Morrison's records confirmed that his fields had been planted exclusively with wheat varieties that were well established and commercially available during their respective time periods. No experimental crops, research plots, or unidentified plant materials had ever been cultivated on Morrison land according to family documentation. Sarah Williams, an agricultural historian with the Washington State Historical Society, researched crop development timelines to verify that the genetic signatures Rodriguez had identified were indeed anachronistic. For 1988 soil samples, the wheat varieties indicated by the soil analysis weren't developed until the mid-1990s, Williams confirmed. Some traits identified in the samples represent breeding work that was still theoretical in 1988. There's no way these genetic markers could be present in soil from fields that have never grown these varieties. Dr. Patricia Mitchell, a soil biochemist from Oregon State University, conducted independent analysis of Rodriguez's samples to verify the methodology and rule out laboratory contamination or analytical errors. Mitchell used different analytical techniques and equipment to eliminate the possibility that the anomalous results were due to procedural problems. The protein signatures are clearly present in the soil samples and represent legitimate plant genetic material, Mitchell reported. The analytical methodology is sound, and I can confirm that the samples contain trace amounts of plant residues with genetic characteristics that postdate the sample collection by several years. The Washington State University administration became concerned about the implications of Rodriguez's findings in late 1988, when preliminary results were discussed at an agricultural science conference in Spokane. University officials worried that reports of impossible crop residues might damage the credibility of the agricultural research program and create confusion among regional farmers. Dr. Harold Santos, Dean of the College of Agricultural, Human, and Natural Resource Sciences, met with Rodriguez in November 1988 to discuss the status of her soil analysis research. Santos expressed concern that the anomalous findings might be misinterpreted by media or agricultural industry representatives if released without comprehensive explanation. Dean Santos suggested that I focus my research on conventional soil chemistry rather than pursuing the genetic analysis that had produced the unusual results, Rodriguez later recalled in a 1995 interview. He noted that funding for my research position was subject to annual review, and that the university needed to maintain strong relationships with agricultural industry partners. Rodriguez was quietly reassigned to different research projects in early 1989, and her soil analysis work was discontinued. Her laboratory records were transferred to university archives and classified as preliminary research data not suitable for publication. Requests for access to the archived data were referred to the university administration and consistently denied. Dr. Chen's genetic analysis report was never published, and his subsequent research focused on conventional wheat breeding programs. Chen declined to discuss the Palouse soil findings in professional settings, noting that speculation about impossible genetic material was not appropriate for academic discourse. The U.S. Department of Agriculture's Soil Conservation Service briefly investigated Rodriguez's findings in 1989, but concluded that the unusual genetic signatures were likely due to analytical limitations, or sample contamination during laboratory processing. The department took no further action and made no changes to standard soil analysis protocols. In 1992, Rodriguez left Washington State University and took a position with a private agricultural consulting firm in California. She signed a non-disclosure agreement related to her university research as part of her departure arrangement, preventing her from discussing or publishing findings from her Palouse soil studies. Morrison continued farming his land using conventional wheat varieties, but reported unusually high yields during the 1990s that exceeded expectations based on regional growing conditions. His wheat consistently tested higher for protein content and drought resistance than neighboring farms using identical seed varieties and farming practices. It's like the soil remembers better varieties than what I'm actually planting, Morrison commented to a regional farming publication in 1996. The wheat grows stronger than it should, like it's pulling genetic information from somewhere other than the seeds I put in the ground. Today, the Palouse Hills continue to produce some of the highest quality wheat in the world, with yields and protein content that consistently exceed national averages. Soil analysis in the region follows standard protocols that focus on nutrient content and chemical composition, avoiding the detailed genetic analysis that might reveal anomalous plant signatures. The archived samples from Rodriguez's 1988 research remain stored in university facilities, labeled as historical agricultural data, with access restricted to authorized personnel. No subsequent research has been conducted on genetic signatures in Palouse soils, and funding for such analysis has been consistently denied by both university and federal agencies. The Morrison Farm continues to produce exceptional wheat harvests, with genetic characteristics that seem to anticipate developments in crop breeding that haven't yet occurred, growing from soil that remembers varieties that were never planted but somehow learned to improve what grows there now, carrying forward improvements that exist only in the earth's quiet preparation for seeds that have yet to be developed. Some directions change with the calendar rather than the compass. The Skagit River flows 160 miles from its headwaters in British Columbia through the North Cascades to Puget Sound, draining one of the largest watersheds in the Pacific Northwest. The river cuts through terrain that includes glaciated peaks over 8,000 feet high, dense temperate rainforest, and fertile agricultural valleys that have supported human settlement for thousands of years. The Skagit system includes 3 major dams that provide hydroelectric power to the Seattle metropolitan area, making it one of the most economically important waterways in Washington state. The river valley has served as a transportation corridor since indigenous peoples first established seasonal camps along its banks. Early European explorers and fur traders followed the Skagit upstream into the Cascade Mountains, using compass bearings and celestial navigation to map routes through difficult terrain. The Washington Territorial Survey documented the river's course in detail during the 1870s, establishing benchmarks and reference points that remain in use by modern surveyors and cartographers. Navigation along the Skagit River follows standard protocols used throughout the Pacific Northwest, with magnetic compass readings corrected for the regional declination between magnetic north and true north. The declination varies slightly across Washington state due to irregularities in the Earth's magnetic field, but these variations are well documented and predictable. Survey maps and navigation charts include declination corrections that allow precise positioning using compass bearings taken from known landmarks. The magnetic anomaly that would challenge these established navigation methods was first documented during a geological survey conducted in September 1972. Dr. Patricia Rodriguez, a geologist with the U.S. Geological Survey, was conducting a mineral resource assessment in the North Cascades as part of a comprehensive study of potential mining sites in the region. The work required precise location mapping using compass bearings and triangulation from established survey markers, techniques that had been standardized for geological fieldwork throughout the western United States. On September 18, 1972, Rodriguez was surveying rock formations along the Skagit River, approximately 15 miles upstream from the town of Concrete, when she noticed that her compass readings were consistently incorrect. Initial bearings to known landmarks showed a deviation of approximately 5 degrees from expected values, suggesting either equipment malfunction or unusual local magnetic interference. "I thought my compass was damaged," Rodriguez wrote in her field notes, "but I had backup instruments that showed the same deviation. Every bearing was consistently off by the same amount, as if magnetic north had shifted several degrees to the east. I rechecked my position using map references and confirmed that my location was correct, but the compass readings were wrong." Rodriguez tested her instruments against known benchmarks and found that compass bearings were accurate outside the immediate vicinity of the river, but showed consistent deviation within approximately half a mile of the Skagit's main channel. The deviation measured exactly 4.7 degrees west of expected magnetic north readings, creating a corridor of magnetic anomaly that extended roughly parallel to the river's course. The discovery prompted Rodriguez to extend her survey work to document the full extent of the magnetic deviation. Over the next 4 days, she mapped the boundaries of the anomalous zone and confirmed that compass readings returned to normal accuracy at distances greater than half a mile from the river. The effect appeared to be limited to a narrow corridor that followed the Skagit's meandering path through the mountain valley. Dr. James Chen, a geophysicist from the University of Washington, joined Rodriguez's survey team on September 23rd to investigate the magnetic anomaly using more sophisticated instruments designed to measure variations in the Earth's magnetic field. Chen's equipment included magnetometers sensitive enough to detect minor fluctuations that might explain the compass deviations Rodriguez had documented. The magnetic field readings were within normal parameters for the North Cascades region, Chen reported in his preliminary analysis. We found no evidence of iron ore deposits, volcanic activity, or other geological features that typically cause magnetic anomalies. The compass deviations were consistent and measurable, but the underlying magnetic field appeared normal. Chen's instruments confirmed that the magnetic anomaly affected only compass needles and other ferromagnetic navigation equipment, while electronic magnetometers showed standard readings throughout the affected area. This suggested that the phenomenon involved compass mechanics, rather than fundamental changes in the Earth's magnetic field. On September 25th, Rodriguez and Chen completed their survey and returned to their respective institutions to analyze the data and prepare reports on the magnetic anomaly. But when Rodriguez attempted to replicate her compass measurements during a follow-up visit in October, she found that all readings had returned to normal accuracy. The 4.7-degree deviation had disappeared completely. Tom Bradley, a Forest Service ranger who had worked in the North Cascades since the 1960s, became aware of the magnetic anomaly through professional contacts at the U.S. Geological Survey. Bradley had extensive experience with wilderness navigation and had never encountered compass problems along the Skagit River during his regular patrols and backcountry assignments. I started paying attention to compass readings during my September patrols after hearing about the survey problems, Bradley told investigators in 1973. Sure enough, during the third week of September, my compass was consistently off by about 5 degrees whenever I was working near the river, but it only happened that 1 week each year. Bradley's observations established that the magnetic anomaly followed a precise annual schedule, affecting compass readings only during a specific time period in late September. His patrol logs from 1973 through 1978 documented the phenomenon occurring during the same week each year, with compass deviations appearing on or around September 20th and disappearing by September 28th. Sarah Williams, a professional surveyor who conducted boundary work for timber companies throughout the Cascade region, encountered the Skagit navigation anomaly during a property survey in September 1975. Williams had 20 years of experience with compass surveying and was familiar with the various factors that could affect magnetic navigation in mountainous terrain. I was running property lines for a timber sale boundary when I realized my compass bearings weren't matching the legal descriptions, Williams recalled. At first, I thought I'd made calculation errors, but when I rechecked everything, the problem was clearly with the compass readings. Every bearing along the river was off by the same amount. Williams completed her survey work using GPS technology and celestial navigation techniques to avoid the compass problems, but documented the magnetic deviations in her field notes for future reference. Her records showed that the anomaly affected all types of magnetic compass equipment, from basic hiking compasses to professional surveying instruments. More disturbing were reports from experienced wilderness guides who relied on compass navigation for backcountry travel along the Skagit River system. Margaret Morrison, who operated guided fishing trips in the North Cascades, described incidents where compass navigation had led groups off established trails during late September expeditions. "I'd been guiding trips on the Skagit for 15 years and knew every trail and landmark," Morrison said during a 1979 interview with Forest Service investigators. "But during that 1 week in September, my compass would take us in the wrong direction every time. I learned to rely on landmarks and GPS during late September trips because the compass couldn't be trusted near the river." The Washington State Department of Fish and Wildlife investigated the navigation anomaly after receiving reports from hunting guides and wilderness outfitters who had experienced similar compass problems during September hunting seasons. The department's investigation focused on potential safety hazards for recreational users who might become lost due to unreliable compass navigation. Dr. Robert Santos, a physicist specializing in geomagnetic research, was contracted by the state to conduct a comprehensive study of the Skagit River magnetic anomaly in September 1980. Santos used sensitive instruments to measure magnetic field variations throughout the affected area and document the precise timing and geographic extent of the compass deviations. The anomaly begins on September 20th and ends on September 27th, with a precision that suggests astronomical rather than geological causes, Santos reported. But no known celestial mechanics can account for localized magnetic effects that follow such a specific schedule. The phenomenon appears to be unique to this geographic location and time period. Santos's research confirmed that the magnetic anomaly was limited to a narrow corridor along the Skagit River and occurred with clockwork regularity during the same week each year. His instruments detected no changes in the underlying magnetic field strength or direction, only the deviation experienced by compass needles within the affected zone. The National Geodetic Survey investigated the Skagit navigation anomaly in 1981 as part of a broader study of magnetic declination variations in the Pacific Northwest. The survey team used the most precise magnetic measurement equipment available to federal agencies, including instruments designed for military navigation applications. "Our measurements confirm the presence of a localized compass deviation that occurs annually during the 3rd week of September," the survey report noted. "However, we find no evidence of magnetic field anomalies that would account for this deviation. The phenomenon appears to affect mechanical compass systems without altering the underlying geomagnetic environment." The Federal Aviation Administration reviewed the survey findings and determined that the Skagit magnetic anomaly posed no threat to aircraft navigation, since aviation relies primarily on electronic navigation systems rather than magnetic compass bearings. No warnings or navigational notices were issued regarding the annual compass deviations. The U.S. Forest Service implemented informal protocols for wilderness rangers working in the North Cascades during late September, recommending the use of GPS navigation and landmark recognition rather than compass bearings when operating within half a mile of the Skagit River. These protocols were never formalized in official regulations, but became standard practice among experienced personnel. Dr. Rodriguez's original field notes documenting the magnetic anomaly were transferred to U.S. Geological Survey archives in 1985 and classified as regional survey data with restricted public access. Subsequent requests for information about the Skagit navigation anomaly have been referred to the National Geodetic Survey, which maintains no active research programs related to the phenomenon. Today, the Skagit River continues to flow through the North Cascades along the same course mapped by territorial surveyors in the 1870s. Modern GPS technology has largely eliminated reliance on magnetic compass navigation for professional surveying and wilderness travel. But during the 3rd week of each September, compass needles throughout the river corridor continue to point 4.7 degrees west of magnetic north, creating a narrow zone where traditional navigation follows rules that change with the calendar rather than the compass. Experienced guides and wilderness professionals who work in the North Cascades have learned to expect the annual navigation anomaly, marking late September on their calendars as a time when the reliable relationship between compass and direction temporarily dissolves. The deviation appears with mechanical precision, lasting exactly 1 week before disappearing until the following year, maintaining a schedule that serves no known purpose but continues with the reliability of something that measures time in ways that have nothing to do with human understanding of how direction should work. Some rhythms exist deeper than memory, older than measurement. Centralia sits in the Chehalis River Valley of southwest Washington, a former logging and coal mining town that reached its peak during the early 20th century. Founded in 1875 by George Washington, a former slave who purchased land along the Northern Pacific Railway line, Centralia developed around timber mills and coal operations that exploited the region's abundant natural resources. The town's location at the confluence of the Chehalis and Skookumchuck rivers made it a transportation hub for moving lumber and coal to markets in Tacoma and Seattle. The geological foundation beneath Centralia consists of sedimentary layers deposited over millions of years, with coal seams that attracted mining operations throughout the late 1800s and early 1900s. The Centralia mine, which operated from 1886 to 1928, extended underground shafts that reached depths of over 800 feet below the town's surface. These mining operations left a network of tunnels and caverns that honeycomb the bedrock beneath the community, though most shafts were sealed when mining ceased to become economically viable. Lewis County established its first seismographic monitoring station in Centralia in 1954, primarily to track earthquake activity related to the nearby Mount St. Helens volcanic complex. The monitoring equipment was installed in the basement of the county courthouse, where thick concrete foundations would provide stable mounting for sensitive instruments designed to detect ground motion from distant seismic events. The seismographic station operated without notable incidents for nearly 20 years, recording typical background seismic activity for the Pacific Northwest region and providing data for earthquake research programs at the University of Washington and the U.S. Geological Survey. On November 12, 1973, seismographic technician Robert Chen noticed an unusual pattern in the data being recorded by the Centralia monitoring station. Chen was reviewing routine seismographic records when he identified a low-amplitude signal that appeared to repeat at regular intervals. The signal was barely detectable above background noise levels, but showed remarkable consistency in both timing and amplitude. Chen initially attributed the pattern to mechanical vibration from nearby traffic or industrial activity, but analysis revealed that the signal occurred at 31-hour intervals, regardless of time of day or local activity levels. The pattern was so regular, it looked like a calibration signal, Chen reported to his supervisor at the Lewis County Emergency Management Office. But our equipment doesn't generate calibration pulses at 31-hour intervals, and the signal appeared to be coming from beneath the ground rather than from the monitoring equipment itself. Chen documented the signal over a 6-week period, confirming that it occurred with mathematical precision every 31 hours. The amplitude remained constant, and the duration was consistently 4.3 seconds. The signal appeared to originate from a depth of approximately 400 feet below the courthouse, placing its source within the geological layers that had been extensively mined during Centralia's coal mining era. Dr. Patricia Rodriguez, a seismologist from the University of Washington, reviewed Chen's data in January 1974 and confirmed that the signal represented genuine seismic activity rather than equipment malfunction or external interference. Rodriguez's analysis indicated that the source was a rhythmic compression and release of rock layers that created detectable ground motion at regular intervals. The signal characteristics suggest a natural source of periodic stress release in the bedrock, Rodriguez noted in her preliminary report. But no known geological processes operate on 31-hour cycles. The periodicity is too regular and too sustained to represent normal seismic activity. Rodriguez recommended expanded monitoring to determine whether similar signals occurred in other areas of Lewis County, but funding for additional seismographic equipment was not approved. The Centralia station continued its routine operations, with the 31-hour signal becoming a familiar background feature in the data records. Local residents began reporting subtle awareness of the seismic pulse during the mid-1970s, though most described the sensation in terms that suggested unconscious rather than deliberate recognition. Margaret Williams, who operated a clock repair shop in downtown Centralia, noticed that customers consistently brought timepieces for adjustment at predictable intervals. People would come in saying their clocks were running slow or fast, and it always seemed to happen around the same time. Williams told county officials during a 1976 community meeting about earthquake preparedness. "I started keeping track, and the pattern was every day and 7 hours. People's internal clocks were somehow getting synchronized to something, but they didn't realize they were doing it." Tom Bradley, who managed Centralia's municipal water treatment facility, documented similar patterns in utility usage that seemed to correlate with the seismic pulse timing. Water consumption and electrical demand showed subtle but consistent fluctuations that occurred every 31 hours, suggesting that residents were unconsciously adjusting their daily routines to match the underground rhythm. "It was like the whole town was keeping time to a beat nobody could consciously hear," Bradley observed in his facility logs. Usage patterns would shift by an hour every few days, following the 31-hour cycle instead of the 24-hour day. People were living slightly out of sync with normal time, and most of them never noticed. More disturbing were reports from residents who became consciously aware of the seismic pulse and found that awareness psychologically unsettling. Sarah Morrison, a high school science teacher who learned about the seismographic data through professional contacts, described feeling increasingly anxious once she began noticing the subtle vibrations. "When you start paying attention to it, you can feel it," Morrison said during a 1978 interview with local newspaper reporters. "It's like a heartbeat in the ground that's just slightly off from normal rhythm. Once you notice it, you can't ignore it. It makes you feel like you're living on top of something that's alive and breathing on its own schedule." Dr. James Mitchell, a geophysicist specializing in underground phenomena, was contracted by Lewis County to investigate the source of the 31-hour seismic signal in 1979. Mitchell used specialized equipment to map the underground structure beneath Centralia and identify possible sources for the rhythmic ground motion. "The signal appears to originate from a depth consistent with the old coal mine workings," Mitchell reported. "But the mining records show that all shafts were properly sealed and flooded when operations ceased. There should be no air spaces or mechanical structures that could generate periodic seismic activity." Mitchell's investigation revealed that the signal source was located directly beneath the intersection of Tower Avenue and Pine Street, in an area where the Centralia mine's main shaft had reached its deepest point. Historical mining maps showed extensive excavation at that location, including large chambers used for coal processing and equipment storage. The Washington State Department of Natural Resources reviewed Mitchell's findings and the historical mining records, but concluded that the sealed mine workings posed no structural threat to surface buildings or infrastructure. The department noted that some groundwater seepage and settling in old mine areas was normal, but found no explanation for the regular 31-hour periodicity of the seismic activity. Dr. Rodriguez attempted to publish her analysis of the Centralia seismic anomaly in the Journal of Geophysical Research, but the paper was rejected by peer reviewers, who noted that regular seismic periodicity at 31-hour intervals lacks precedent in documented geological processes. Her research data was archived by the University of Washington and classified as Regional Seismic Monitoring Records with limited public access. The Lewis County Emergency Management Office discontinued detailed analysis of the 31-hour signal in 1981, noting that it posed no apparent hazard to public safety and represented a normal background feature of local seismic activity. Chen was transferred to a different monitoring station, and routine seismographic analysis at Centralia was limited to earthquake detection and magnitude measurement. In 1985, the Centralia Seismographic Station was upgraded with digital recording equipment that filtered out low-amplitude signals to focus on significant seismic events. The digital filters were calibrated to eliminate the 31-hour pulse, which was classified as local background noise rather than meaningful seismic data. Mitchell's geophysical survey equipment was returned to the university when his contract ended, and no follow-up studies of the underground structure beneath Centralia were conducted. His research files were transferred to the Washington State Archives and remain available only to qualified researchers with specific academic credentials. Today, Centralia maintains its small-town character as a regional center for agriculture and light industry. The former mining areas have been converted to parks and recreational facilities, with no visible reminders of the extensive underground excavations that once characterized the local economy. The county courthouse continues to house seismographic monitoring equipment, though the instruments now focus on detecting major earthquakes rather than documenting subtle ground motion. Residents continue to live their daily routines with unconscious awareness of the 31-hour rhythm that pulses beneath their community. Local businesses still experience subtle fluctuations in customer activity that follow the underground beat rather than conventional daily schedules. Clocks throughout Centralia still require adjustment at intervals that correspond to something deeper than mechanical timekeeping, synchronized to a pulse that keeps its own measure of time. The seismographic signature continues to appear in digital records as background data that automated systems filter out before analysis, maintaining its perfect 31-hour periodicity without explanation or investigation. Deep beneath the streets and homes of Centralia, something continues to mark time in rhythms that predate human measurement. Keeping a beat that residents follow without knowing they're dancing to music that plays from chambers sealed before their grandparents were born, echoing with the patience of something that has learned to count time in increments that serve purposes no living person remembers. Some destinations exist only in the schedules that serve them. Lummi Island sits in the northern reaches of Puget Sound, separated from the Washington mainland by Hale Passage, a narrow channel that requires ferry service to connect the island's 700 residents with the outside world. The island stretches 9 miles north to south and 2 miles east to west, its shoreline consisting of rocky beaches, small harbors, and the single ferry terminal at Gooseberry Point on the western shore. The Washington State Ferry System has maintained regular service to Lummi Island since 1958, operating small vessels that make the 20-minute crossing from the mainland terminal at Gooseberry Point. The island's history includes coast sailor settlements dating back thousands of years, followed by European homesteading in the late 1800s and development of small fishing and farming communities. By the mid-20th century, Lummi Island had evolved into a quiet residential community, attracting retirees, artists, and summer residents seeking isolation and natural beauty. The population remains stable at fewer than 800 residents, served by a single general store, volunteer fire department, and the ferry connection that represented their only reliable link to mainland services. Washington State Department of Transportation ferry schedules are meticulously maintained documents that list departure times, destinations, and vessel assignments for each route in the state system. These schedules undergo regular review and revision based on passenger demand, maintenance requirements, and budget allocations. The Lummi Island route operated with predictable efficiency, providing multiple daily departures that served commuters, residents, and occasional tourists visiting the island's beaches and hiking trails. The administrative anomaly that would challenge the ferry system's documentation began appearing in printed schedules distributed throughout the San Juan Islands region during the summer of 1985. Patricia Rodriguez, a travel writer researching ferry services for a guidebook about Washington State Islands, was reviewing ferry schedules at the Anacortes terminal when she noticed an inconsistency in the Lummi Island service listings. The schedule showed regular departures to two destinations, Lummi Island and East Lummi, with identical 20-minute crossing times, but different departure docks at the Gooseberry Point terminal. I asked the terminal agent about service to East Lummi because I wanted to include all available destinations in my guidebook, Rodriguez later told Washington State Ferry investigators. The agent looked confused and said there was only one Lummi Island route, but the printed schedule clearly showed two destinations with different dock assignments. Rodriguez attempted to purchase a ticket to East Lummi, but was told by ticket agents that no such destination existed in the ferry system's computer database. The automated ticketing system recognized only Lummi Island as a valid destination, yet the printed schedules continued to list East Lummi service through the summer and fall of 1985. Dr. James Mitchell, a cartographer from Western Washington University, became aware of the East Lummi schedule anomaly through professional contacts in the tourism industry. Mitchell's expertise in Pacific Northwest geography and maritime navigation made him qualified to investigate whether East Lummi represented an unmapped location or administrative error. I reviewed every available map and chart of the Lummi Island area, Mitchell reported to the Washington State Department of Transportation in October 1985. There is no geographic feature that could be designated as East Lummi. The island has only one ferry-accessible landing point, which is the established terminal on the western shore. Mitchell's analysis of nautical charts, aerial photographs, and geological surveys confirmed that Lummi Island contained no secondary ferry terminals or alternative landing sites that could support passenger service. The waters around the island were too shallow in most areas to accommodate ferry operations, and the shoreline geography provided no suitable locations for dock construction. Local residents began reporting unusual passenger activity during the winter of 1985 and 1986, as travelers occasionally appeared at the Lummi Island terminal, claiming to have traveled on East Lummi ferry service. Margaret Williams, who operated the island's only taxi service, encountered several confused passengers who insisted they had boarded ferries to East Lummi from the mainland. People would get off the regular ferry and ask me to take them to the East Lummi terminal for their return trip, Williams told ferry system investigators. When I explained there was only one ferry dock, they'd show me their tickets or schedules that listed East Lummi as their destination. They seemed genuinely confused about where they were supposed to be. Tom Bradley, the ferry terminal manager at Gooseberry Point, documented increasing inquiries about East Lummi service from passengers who appeared to have legitimate travel documents. Bradley's daily logs from 1986 and 1987 show regular entries recording passenger complaints about missed East Lummi departures and confusion about dock assignments for the non-existent route. Passengers would arrive with printed schedules showing East Lummi departure times, Bradley noted in his operational reports. The schedules looked official and matched our standard format, but our computer system showed no record of issuing tickets for those departures. It was like people were getting authentic ferry schedules for routes that didn't exist. More disturbing were accounts from passengers who claimed to have successfully traveled to East Lummi and described their experiences on what they insisted was a different version of Lummi Island. Sarah Morrison, a Seattle resident who regularly visited the San Juan Islands, provided detailed testimony about an East Lummi trip she claimed to have taken in June 1987. The ferry crossing was normal, about 20 minutes from Gooseberry Point, Morrison told investigators. But when we arrived, the island looked different. The buildings were older, the cars were from the 1960s, and everyone was dressed like it was decades earlier. When I asked locals about the date, they insisted it was 1962. Morrison described East Lummi as identical to Lummi Island in geography and layout, but populated by residents who appeared to be living in a different time period. The general store stocked merchandise from the 1960s, local newspapers carried dates from that era, and residents exhibited no awareness of events that had occurred after 1962. Dr. Robert Santos, a psychologist specializing in memory and perception disorders, reviewed testimony from passengers who claimed East Lummi experiences. Santos was contacted by ferry system administrators who were concerned about the consistent nature of the reports and the mental health implications for affected travelers. The accounts show remarkable consistency in detail and emotional authenticity, Santos noted in his clinical assessment. Passengers describe experiences that feel completely real to them, including specific sensory details and social interactions. These don't appear to be fabricated stories or attention-seeking behavior. Santos documented that East Lummi passengers consistently reported the same temporal displacement, arriving at a community where residents believed the year was 1962. The descriptions included specific details about clothing, technology, and cultural references that suggested either elaborate preparation or genuine experience of some kind of temporal anomaly. The Washington State Department of Transportation launched a comprehensive investigation of the East Lummi ferry schedule anomaly in 1988, focusing on identifying the source of the unauthorized schedule entries and preventing continued passenger confusion. The investigation team included ferry operations managers, computer systems specialists, and administrative staff responsible for schedule production and distribution. The investigation revealed that East Lummi schedule entries appeared in printed materials, despite having no corresponding entries in the ferry system's master database. The schedules were produced by the same printing contractor used for all official ferry publications, using the same paper stock, fonts, and formatting as legitimate schedules. The East Lummi schedules are indistinguishable from our official publications, reported Transportation Department investigator Jennifer Walsh. They're printed on our standard paper, using our approved formats and distributed through the same channels as legitimate schedules. But there's no record in our computer systems of creating or authorizing these documents. Walsh's investigation team interviewed printing company staff, ferry terminal personnel, and administrative officials throughout the Washington State ferry system, but found no individual who admitted knowledge of East Lummi schedule production or distribution. The schedules appeared to generate themselves within the established publication process without human intervention or authorization. The U.S. Coast Guard reviewed reports of East Lummi ferry service and conducted maritime safety inspections of the Lummi Island area to verify that no unauthorized passenger operations were occurring in Puget Sound waters. Coast Guard investigators found no evidence of vessels operating passenger service to uncharted destinations or unofficial landing sites. Some currents remember directions that defy the pull of Earth. The Snake River forms the border between Washington and Idaho as it winds through Hell's Canyon, the deepest river gorge in North America. The river drops over 1,000 feet in elevation as it cuts through basalt layers that tell the geological history of the Columbia Plateau, creating rapids and pools that have challenged navigators since Lewis and Clark documented the treacherous passage in 1805. Assotin County encompasses the Washington shore of this remote section, where steep canyon walls rise over a mile above the river, and road access requires winding mountain routes that descend through terrain carved by millions of years of water flow. The Snake River's current follows the inexorable pull of gravity toward its confluence with the Columbia River, carrying snowmelt from the Rocky Mountains through 800 miles of canyon country to the Pacific Ocean. The flow rate varies seasonally, from winter lows of around 10,000 cubic feet per second to spring peaks that can exceed 100,000 cubic feet per second during heavy snowmelt periods. But the direction never varies. The water always flows northwest toward the Columbia. following gradients that have remained constant since the river established its current course. Asotin County has maintained hydrological monitoring stations along the Snake River since 1958, collecting data on flow rates, water temperature, and river conditions that affect both recreational use and downstream dam operations. The monitoring equipment includes automated sensors that record water velocity and direction 24 hours per day, providing continuous documentation of river behavior throughout seasonal and weather-related variations. The discovery that would challenge fundamental assumptions about river hydraulics occurred during routine data analysis conducted by the Washington State Department of Ecology in April 1976. Hydrologist Dr. Margaret Rodriguez was reviewing quarterly flow data from the Snake River monitoring stations when she noticed an anomaly in the velocity measurements recorded on March 20th, 1976, the date of the spring equinox. For a 4-hour period, beginning at 6:47 in the morning, the monitoring station near Asotin recorded negative flow velocities, indicating that water was moving upstream against the river's normal current direction. I assumed the monitoring equipment had malfunctioned, Rodriguez later reported to her supervisor at the Department of Ecology. Negative flow readings suggested that water was flowing uphill, which is physically impossible in a natural river system. I requested maintenance checks on all instruments, but the equipment tested normal when technicians arrived the following week. Rodriguez reviewed historical data from the same monitoring station and found no previous instances of negative flow readings. The March 20th anomaly appeared to be unique, lasting exactly 4 hours and showing consistent upstream velocity measurements throughout the affected period. Water flow rates during the reversal matched typical spring conditions, but in the opposite direction from normal river flow. The phenomenon repeated on March 20th, 1977, with identical characteristics. 4 hours of upstream flow beginning at approximately 6:45 in the morning, recorded by instruments that functioned normally before and after the reversal period. Rodriguez documented the repeat occurrence and requested permission to conduct field observations during the next spring equinox to verify the instrument readings with direct visual confirmation. Dr. James Chen, a hydraulic engineer from Washington State University, joined Rodriguez for field observations on March 20th, 1978. Chen brought additional monitoring equipment and expertise in river hydraulics to investigate what appeared to be an impossible reversal of gravitational flow. The team positioned themselves at the Asotin monitoring station before dawn to observe the river conditions during the predicted reversal period. At approximately 6:45, we observed the river current slow, stop, and begin flowing upstream, Chen documented in his field report. The reversal was gradual, but unmistakable. Debris and foam that had been flowing downstream turned and began moving back upriver. The water surface showed the characteristic patterns of upstream flow, with eddies and current lines indicating movement against the river's normal direction. Chen's measurements confirmed that water was indeed flowing upstream during the 4-hour period, creating a localized reversal that extended approximately 3 miles along the Snake River Canyon. The upstream flow rate measured between 800 and 1,200 cubic feet per second, substantial volumes of water moving against gravity, with no apparent mechanical force to drive the reversal. We documented a clear violation of gravitational flow principles, Chen noted. Water was flowing uphill at measurable rates, sustained for 4 hours, then returning to normal downstream flow as if nothing unusual had occurred. No known hydraulic phenomenon can account for this behavior. Local fishing guides had been observing unusual river conditions during late March for several years before the scientific documentation began, though most attributed the changes to seasonal variations or upstream dam operations. Tom Bradley, who operated guided fishing trips in Hell's Canyon from 1970 through 1995, noticed that fish behavior changed dramatically during spring equinox periods. The fish would stop biting right around dawn on March 20th, Bradley told Chen during a recorded interview. Not just feeding less, they'd completely disappear for about 4 hours. The river would look different too, like the current was confused about which way it was supposed to go. I learned to schedule trips around that time, because the fishing was always terrible. Bradley's fishing logs documented the annual pattern of poor fishing conditions on March 20th, but also revealed something more disturbing. Fish caught immediately after the 4-hour period exhibited unusual characteristics that affected their taste and texture. Fish we caught right after the weird current behavior tasted wrong, Bradley reported. Not spoiled or diseased, but different. Like they'd been swimming in different water, or swimming the wrong direction for so long that it changed something about them. Clients complained, and I stopped keeping fish caught during that time period. Sarah Williams, a marine biologist from the University of Idaho, analyzed fish samples provided by Bradley during the 1979 spring equinox period. Williams's laboratory analysis focused on potential water quality issues or contamination that might explain the taste differences Bradley had observed. The tissue analysis showed no evidence of toxins, parasites, or unusual mineral content, Williams reported. But the cellular structure of muscle tissue showed stress patterns consistent with extended swimming against strong currents. The fish appeared to have been working much harder than normal, as if they'd been fighting upstream flow for hours. Williams's analysis suggested that fish caught during the reversal period had indeed been swimming against unusual current conditions, supporting the hydrological measurements documenting upstream water flow. But the biological evidence raised additional questions about how fish responded to current reversals that lasted only 4 hours, but appeared to create lasting physiological effects. Margaret Morrison, a geologist with the U.S. Army Corps of Engineers, investigated the Snake River reversal phenomenon in 1980 as part of a broader study of unusual hydraulic conditions affecting dam operations throughout the Columbia River system. Morrison's analysis focused on determining whether upstream dam releases or mechanical factors could account for the annual flow reversals. We analyzed upstream dam operations for the entire Columbia River system during March 20th periods from 1976 through 1979, Morrison reported. No dam releases, maintenance operations, or mechanical factors corresponded to the timing of the Snake River reversals. The phenomenon appears to be independent of human water management activities. Morrison's investigation revealed that the flow reversal occurred in a section of the Snake River that was over 200 miles downstream from the nearest dam, making it impossible for upstream water releases to affect current direction in the Assoutine area. The gradient of the river channel in the affected section was consistent with normal downstream flow, providing no topographical explanation for periodic upstream movement. The Washington State Department of Fish and Wildlife opened an investigation into the Snake River reversal in 1981, prompted by reports from fishing guides and concerns about potential effects on salmon migration patterns. The department's aquatic biologists were particularly interested in understanding how annual current reversals might affect fish populations that relied on predictable flow conditions for spawning and feeding. Dr. Patricia Walsh, the department's senior fish habitat specialist, conducted underwater observations during the March 20th, 1982 reversal using scuba equipment and underwater cameras. Walsh's documentation provided the first direct visual evidence of the hydraulic anomaly and its effects on aquatic life. The underwater footage clearly shows debris, sediment, and fish moving upstream during the reversal period, Walsh reported. Fish appeared disoriented and exhibited erratic swimming behavior, as if they were struggling to adapt to current conditions that contradicted their normal environmental cues. Some species seemed to stop moving entirely during the reversal, as if waiting for normal flow conditions to resume. Walsh's underwater observations revealed that the current reversal was complete and sustained throughout the affected river section. Water movement, sediment transport, and aquatic life all responded to upstream flow that persisted for the full 4-hour period, before returning to normal downstream patterns. The U.S. Geological Survey dispatched a team of hydrologists to investigate the Snake River reversal in March 1983, using advanced flow measurement equipment and computer modeling to analyze the hydraulic mechanics of upstream water movement in a gravitational environment. The team was led by Dr. Harold Santos, a specialist in unusual river hydraulics who had experience with tidal bores and other complex flow phenomena. We measured sustained upstream flow rates, averaging 1,000 cubic feet per second over a 3-mile river section, Santos documented. The water was definitely flowing uphill against a measurable gradient. Computer models indicate that maintaining this flow rate would require external energy input, equivalent to approximately 50,000 horsepower. But we found no energy source that could drive such massive water movement. Santos's team attempted to identify possible explanations for the annual reversal, including underground springs, seismic activity, or atmospheric pressure variations that might temporarily overcome gravitational flow. But none of these factors showed correlation with the March 20th timing or the specific geographic location of the reversal. The investigation expanded to include geological surveys of the river bottom in the affected area, using sonar equipment and core sampling to map subsurface features that might influence water flow. The surveys revealed typical Snake River geology: basalt bedrock, overlaid with sediment deposits, with no unusual formations that could redirect water flow or provide alternative channels. More concerning were reports from hydrologists and engineers who attempted to study the reversal using sophisticated measurement equipment. Several researchers reported equipment malfunctions or data anomalies that occurred specifically during the 4-hour reversal periods, as if the unusual hydraulic conditions interfered with electronic instruments. Dr. Jennifer Mitchell, a hydraulic engineer from the Bureau of Reclamation, experienced instrument failures during the 1984 spring equinox observation. Our electronic flow meters stopped functioning at the moment the reversal began, Mitchell reported. The instruments worked normally before and after the event, but during the 4-hour upstream flow period, all electronic measurement systems showed null readings or error codes. The consistent instrument failures suggested that the Snake River reversal involved more than simple current direction changes. Electronic systems that functioned reliably under all other conditions became unreliable, specifically during the annual upstream flow periods, limiting researchers' ability to document the phenomenon using modern technology. The Washington State Department of Ecology classified the Snake River reversal data as anomalous hydrological observations in 1985 and transferred responsibility for monitoring to federal agencies. The U.S. Geological Survey assumed oversight of data collection, but noted that the phenomenon fell outside standard hydrological research parameters. Dr. Rodriguez's original reports documenting the flow reversal were archived and classified as regional hydraulic data, with restricted public access. Subsequent research requests related to the Snake River anomaly have been referred to the Bureau of Reclamation, which maintains no active programs for investigating gravitational flow reversals. Local fishing guides continue to avoid the affected section of the Snake River during late March, though official reasons cited include seasonal fishing closures and spawning habitat protection rather than hydraulic anomalies. Guides who work other sections of the river report that the March 20th period has become known as Dead Water Day among professionals familiar with the area. Today, the Snake River continues its ancient course through Hell's Canyon, carrying mountain snowmelt toward the Columbia, with the same gravitational certainty that has driven its flow for millions of years. But once each year, for exactly 4 hours, a 3-mile section remembers a different direction and flows upstream with the determination of water that has learned to defy the very forces that created the canyon through which it moves, creating a brief annual rebellion against gravity that leaves no explanation except the lingering taste of fish that swam the wrong way through time, that moved backward, carrying the memory of currents that flowed against the world.